There's a quiet idea drifting through the world of physics, a thought that begins like a whisper and grows into something almost unbelievable. It says, a black hole is a place where even light finds no path out. So what would it mean if our entire universe is one of those places? Let's put some base information on the table gently. Imagine a region of space where every path curves inward, where gravity bends the rules so deeply that nothing, not even a photon, can escape its pull. And now imagine looking around at the cosmic horizon of our universe and seeing hints that it behaves the same way. Welcome to AstraFlow. Here, science drifts like starlight, and curiosity becomes calm. Tonight, let your thoughts slow down, your breathing find its rhythm, and your mind float through wonder. Before we begin, I'd love to know where you're listening from. Are you lying in bed under city lights, or watching the stars from somewhere quiet? Tell me in the comments. It's always peaceful to imagine the AstraFlow community scattered across the world, drifting together through the same sky. And if this calm journey brings you peace, you can gently support AstraFlow by liking this video or subscribing. It helps this little corner of the cosmos keep glowing. Now, let's step softly into tonight's voyage, a journey into the quiet possibility that our universe might be living inside a black hole. To begin, picture a horizon stretched across the night, a boundary not made of earth or water, but of pure space-time, a place where information cannot reach beyond, because the universe simply hasn't lived long enough for the light to get there. Scientists call this our cosmic horizon, the farthest edge of visibility. It is the place where the story of the universe fades into silence, and now, placed beside it, another horizon, the event horizon of a black hole. This one-way boundary looks strangely familiar. It is also a limit beyond which no light escapes, no message returns, and all futures bend inward. The resemblance between the two is more than poetic, it is mathematical. When physicists calculate the size of a black hole that contains the same mass as our universe, the size of its event horizon matches almost perfectly with the size of our observable cosmos. Our density matches too. The numbers, placed quietly side by side, line up in a way that makes even careful scientists pause. Is it coincidence? Or is our universe not just floating in empty space, but inside something larger, something curved, something born from collapse? Tonight we explore that possibility, not with urgency, but with gentle curiosity. We'll drift through the nature of black holes, the architecture of horizons, the strange hints of cosmic rotation, and the idea that maybe, just maybe, our Big Bang was the opening bloom of a black hole in another universe. Let your breath settle, let your shoulders loosen, and allow yourself to drift with this thought. If we're inside a black hole, then the universe is not a cage, but a cradle. There is a question that lingers softly at the edge of modern cosmology, a question so large it feels almost like a dream. It asks, what does inside even mean when we speak of a universe? In our everyday lives, inside is simple. Inside a room, inside a house, inside a quiet moment. But when the question rises into the scale of galaxies and horizons, the word begins to stretch. Its meaning thins out, softens, becomes something more fluid, more mysterious. And tonight, we follow that question as it drifts past the boundaries of ordinary thought toward a horizon of possibility. Imagine stepping out under a silent sky and looking upward until your neck grows light. Somewhere above you, beyond every star you can name, lies a distance where light has been travelling since the beginning of time and still hasn't reached us. That hidden boundary, the cosmic horizon, is the farthest line our universe has allowed us to see. Not because there is nothing beyond it, but simply because the universe hasn't lived long enough for that light to arrive. Time itself draws the line. Now gently place this idea beside the nature of a black hole. A black hole also has a horizon, a limit beyond which nothing returns, a place where time flows differently, where gravity bends space into a quiet inward curve. The shape of this boundary, the way it traps information, the way it defines a region of unseen interior, all of it echoes the structure of the horizon that surrounds our entire universe. Two horizons separated by scale, yet whispering the same language. And so, the question rises softly. If horizons define both black holes and the universe itself, what makes one inside and the other outside? Where is the line that separates a cosmos from a collapsed star? And what would it feel like if we were already living inside a horizon we cannot cross? This is not a question we answer with certainty. It is a question we approach with breath, slow, calm, deliberate, because it is made of wonder rather than proof. Scientists don't present this idea as a final truth, but as a doorway, a possibility, a point of quiet reflection where mathematics and imagination sit down together and look at the same sky. The horizon of a universe is unlike any horizon we know. It doesn't block us, it doesn't imprison us. It simply marks the farthest distance the universe has had time to illuminate. It is not a wall, it is a moment, a breath. And every second that passes, the horizon grows wider. Every moment, new light arrives. Every instant, the universe reveals a little more of its interior. So the question becomes more delicate. If horizons can grow, can a black hole's interior grow as well? If our universe has an age and a size and a density matching that of a black hole, could both be reflections of the same structure, not an answer, not a declaration, just a possibility drifting gently above our heads? As you breathe slowly, imagine the cosmos as a room whose walls are made of time, a room expanding softly, endlessly, a room with edges defined not by what is absent, but by what has not yet arrived. And within that room, you, made of atoms forged in ancient stars, lie cradled in a story still unfolding. Tonight, as we move deeper into this journey, we will follow the lines of this question. We will explore the quiet architecture of black holes, the strange hints of cosmic rotation, the way space-time behaves when boundaries curve inward, and slowly, gently, we will approach the heart of the idea. Could our universe be the interior of a black hole in a larger cosmos? For now, let the horizon remain where it is, a soft boundary, a silent question, a place where wonder begins. Let's take a gentle step deeper into the soft glow of possibility. When scientists speak about the idea that our universe might be inside a black hole, they are not offering a wild fantasy. They are looking at patterns, quiet, mathematical patterns, and noticing that some of them line up in ways that are hard to ignore. Tonight we won't treat this as a claim. We won't treat it as an answer. We will treat it as a calm, thoughtful hypothesis, a way of looking at the universe that opens the mind rather than closing it. To begin, imagine the universe not as an empty void, but as a structure with a horizon set not by a wall, but by time. The farthest galaxies we can see are the ones whose light has just now reached us after nearly 14 billion years of travel. Everything beyond that distance is hidden from view, not because it isn't there, but because the universe hasn't existed long enough for their light to arrive. This horizon is our limit. It forms the boundary of the observable cosmos. Now place this idea beside a black hole's event horizon. A black hole forms when a massive star collapses under its own gravity, compressing matter into a region so dense and curved that space-time folds inward. At the edge of that inward fold sits the event horizon, a boundary beyond which nothing returns, not because things are destroyed instantly, but because the very geometry of space-time guides everything inward. For anyone inside, the event horizon is a silent shelter. For anyone outside, it is an impenetrable veil. And here is where curiosity begins to bloom. When you calculate the size of a black hole that contains the same mass as our universe, its event horizon has the same radius as our cosmic horizon. The numbers align almost perfectly. The average density of matter inside our cosmic horizon also matches the density you would expect inside a black hole of the same size. These parallels are not proofs, but they are patterns. Soft, persistent, intriguing patterns. Some cosmologists have suggested that what we call the Big Bang, the explosive, expanding birth of everything, might not have been an explosion at all. Instead, it might have been the moment when space-time inside a collapsing star opened into a new region. In other words, when the core of a dying star in another universe collapsed into a black hole, the interior may have unfolded into a new cosmos, ours. This idea, often called the black hole cosmology hypothesis, proposes that black holes are not just endpoints but beginnings, that each collapsing star may give rise to a new universe, sealed inside its own horizon. These child universes would inherit two things from their parents: mass and angular momentum, the cosmic spin, and intriguingly, those are exactly the two large-scale properties we can measure in our own universe. There's another thread here, subtle but beautiful. General relativity, Einstein's framework for understanding gravity, predicts that the interior of a black hole is not a single point of destruction. Instead, it may be a new direction in space-time, a new expansion, a new beginning. Time, inside, may flow forward in a different way. Space may stretch in a different direction. Entire cosmic histories could unfold quietly beyond the horizon. Maybe that is what happened to us. Maybe our universe is an interior, a quiet room in a larger house of reality. None of this is certain. None of it needs to be. What matters tonight is that it gives us a way to wonder, to breathe into the unknown, to let our thoughts drift softly across the boundaries of everything we've ever known. As we move forward, we'll explore the structures of black holes, the hints of cosmic rotation, and the way space-time behaves when boundaries curve inward. Slowly, we'll build a landscape where this hypothesis feels not wild, but peaceful, a possibility worth drifting through. A black hole is often imagined as a monster of the cosmos, a devouring mouth in the fabric of space. But the truth, when we slow down and listen carefully to the physics, is far quieter. A black hole is not a creature. It is not a danger lurking in the dark. It is a shape, a curvature, a region where gravity has pressed space-time into a form so deep, so smooth, so inward-leaning that everything, matter, light, even time, follows the same path, the path toward the center. To understand it gently, imagine a calm ocean with a deep whirlpool forming in its heart. The surface of the water curves downward, and anything drifting nearby begins to slide inward. Not because it is pulled violently, but because the geometry of the water has changed. A black hole is something like that, except the ocean is space-time itself. Black holes begin their lives simply. A massive star, larger than our sun by many orders of magnitude, burns through its fuel. When the fuel runs out, the star loses its inner pressure and collapses under its own gravity. If the star is heavy enough, that collapse continues without stopping. Matter squeezes tighter and tighter until the laws of physics as we know them can no longer describe what happens next. We meet something new, a region where density becomes extreme and curvature becomes profound. The space around this region is where the black hole truly reveals itself. Gravity near a black hole is not a force pulling things in. Instead, the geometry of space-time itself leans inward. It curves. It folds. All paths, straight lines, curved lines, paths of light, begin to bend toward the center. Even time behaves differently here. Clocks near a black hole tick slower. Signals weaken. Light reddens and stretches. To an outside observer, anything falling in seems to freeze at the edge, fading into darkness. But from the inside, the story is different. Inside, things move forward. Inside, time continues. Inside, a new region of space-time opens up. A region predicted by the equations of general relativity, even if our intuition struggles to imagine it. This is one of the reasons black holes fascinate cosmologists. They blur the line between endings and beginnings. What appears from the outside as a place where information is lost may, from another perspective, be a place where new information is born, a place where space-time extends in ways we cannot yet see. And there is something beautifully simple about the way black holes carry information. No matter how complex the things falling in, stars, planets, clouds of gas, the black hole remembers only two large-scale properties: the total mass and the total angular momentum, the overall spin. Everything else becomes part of the quiet interior. This fact will gently return to us later, when we explore the strange hints that our universe may have a net rotation, a twist, a subtle motion inherited from something before. For now, hold this image softly. A black hole is not destruction. It is transformation, a star collapsing into a new geometry, a region of space-time curling inward like a deep breath. A shape so smooth and complete that it becomes a world unto itself. If our universe were born from such a place, then we are not living inside violence or chaos. We are living inside the unfolding interior of a cosmic transformation, a quieter story written in the curvature of space-time. Every black hole has a boundary that feels almost mythic in its simplicity, a place where the universe draws a soft line and says, "Beyond this, the rules are different." This boundary is called the event horizon, and despite the mystery woven around it, its nature is quiet, almost elegant. It is not a wall, not a surface, not a barrier you could touch. It is simply a point of no return, a place where the geometry of space-time curves so deeply inward that all future paths lead to the same destination. To imagine the event horizon gently, think of walking toward the edge of a hill at dusk. The slope begins to tilt and each step leans you forward just a little more. Eventually you reach a place where every footstep naturally carries you downward, even if you try to lean back. The event horizon is like that final step, except instead of a hill, it's space-time itself that slopes inward. From the outside, the edge appears silent. If you watch someone fall toward it, you would see them slow down. Their movements would stretch, then freeze, then fade, as the light carrying their story loses energy and reddens into darkness. To an outside observer, nothing ever truly crosses the horizon. Time appears to stop. The fall becomes eternal. But time behaves differently for the one who falls. From the inside, there is no pause, no freezing, no sense of crossing a dramatic border. Instead, the faller drifts smoothly inward, as if passing through a doorway without realizing it. The geometry simply shifts. Light no longer leads outward, it flows inward. Every possible path bends the same way. This asymmetry between what the outside sees and what the inside experiences is one of the most fascinating features of relativity. It is a reminder that reality depends on perspective. Two observers can witness the same moment in space-time and disagree completely about what happened, and both can be right. What makes the event horizon so relevant to our cosmic story is that our universe has something very similar. There is a distance so far away that the light from beyond it will not reach us. Not today, not tomorrow, not in another trillion years. Not because something blocks it, but because space itself is expanding. The horizon marks a place where the fabric of the universe grows faster than light can travel back. This cosmic horizon is not identical to an event horizon, but the resemblance is striking. Both boundaries mark where information can no longer reach an observer. Both create a region beyond which the future is sealed off. Both shape the structure of the world inside. And here is where the mystery deepens. When curious physicists calculated the radius of a black hole that would contain the same mass as our universe, the size of its event horizon matched the radius of our observable cosmos, almost exactly. This raises a whisper of a question. If our universe has a boundary that behaves like an event horizon, and its size aligns with what a black hole of our mass would look like, could the universe itself be the interior of something larger? Tonight we continue drifting toward this idea slowly, without urgency. The event horizon is not an answer, it is a clue. A soft hint that the structures we see in the cosmos may mirror structures that arise inside collapsed stars. As we move forward, hold this image. A horizon not as an ending, but as a beginning you cannot return from. A doorway into a region where space-time opens in directions we have not yet imagined. Imagine drifting toward the heart of a black hole, not as a violent plunge, but as a slow surrender to the shape of space-time. In the popular imagination, falling into a black hole is often pictured as chaotic, tearing, crushing, collapsing. But the truth, when described with the calm language of relativity, is more subtle, more silent, more like drifting downstream on a river whose current grows stronger with every passing moment. There is no jolt, no sudden snap, just an increasing inward pull, a curvature of the world that guides everything gently toward the centre. To understand this fall, picture yourself floating in open space. One moment, the future ahead of you allows endless directions. You can move sideways, backward, outward. But as you approach a black hole's event horizon, the geometry begins to change. The number of futures you can choose from softly begins to shrink. The options narrow, until, finally, all possible paths, every straight line, every curved trajectory, even the beams of light leaving your fingertips, tilt in the same direction. Inward, always inward. This is the true nature of falling into a black hole. You do not fall because something pulls you in. You fall because space-time itself curves and you are simply following its natural shape. It is the same reason planets orbit stars and light bends around galaxies, not because of a force, but because geometry guides motion. From your own perspective, the fall feels ordinary. Your heartbeat stays the same. Your thoughts drift. Time flows forward in its steady rhythm. You do not notice the precise moment you cross the event horizon. There is no signpost, no boundary line. You drift inward as gently as a feather settling onto a quiet floor. But to someone watching from far away, the story looks different. They would never see you cross the horizon at all. Instead, your motion slows, stretches, freezes. The light you emit grows red and faint, as if fading into sunset. To them, you become a still image on the edge of forever. Two perspectives, both true. Two experiences shaped by space-time itself. Now imagine continuing deeper. Inside the horizon, something remarkable happens. The inward direction becomes your new time direction. Moving inward is not a choice. It is the future. Space-time narrows toward a point, guiding everything closer and closer together. This inward future is what physicists call the singularity. Though even they admit the term hides more than it explains, it may not be a destructive point at all. It may be a doorway. A place where the equations of general relativity hint at new space-time opening up. A new universe unfolding, where the story begins again. This is where the black hole universe hypothesis becomes truly poetic. If falling inward becomes the future, and if that inward future leads to an expanding region of space-time, then your fall does not end. It transforms. A collapsing star could give birth to a new universe, whose inhabitants never see the collapse, only the expansion. Their beginning, their Big Bang, could be the interior of a deeper gravitational transformation. If we are living inside such a universe, then the fall toward the centre happened long before the first atoms formed. We are not plunging now. we're living inside the result, the quiet aftermath of a collapse that opened into a vast, expanding cosmos. The singularity is not behind us as destruction, it is behind us as birth. So as you breathe gently, imagine falling not as fear, but as flow, not as an ending, but as the natural step that led to the spacious universe you drift in tonight. Every star, every galaxy, every moment of your life may be part of that gentle inward movement, the memory of a fall that became creation. There is a quiet idea in modern cosmology that feels as poetic as it is scientific. Every black hole might be the seed of a new universe, not an ending but a beginning, not destruction but transformation, a moment where a star collapses inward, and in that collapse, a new cosmos quietly unfolds inside. To understand this possibility, imagine watching a massive star at the end of its life. For millions or even billions of years, it burned with fierce equilibrium, gravity pulling inward, pressure pushing outward, forming a perfect balance. But eventually the fuel runs out. The outward push weakens, gravity wins. What was once a star begins to collapse, gathering itself into a tighter and tighter space. To an outside observer, this collapse looks like a star shrinking into darkness. But according to the mathematics of general relativity, something astonishing may happen inside. As matter compresses and gravity curves space-time, the interior doesn't necessarily shrink to a single point. Instead, it may open, not outward, but inward, into a new dimension, a new direction of expansion, a new region of space-time. This interior expansion could look from the inside exactly like a Big Bang, a sudden stretching of space, a surge of temperature and energy. A fireball blooming into a vast smooth cosmos, and from that first flash, a universe begins to cool, expand and form structure, stars, galaxies, planets, life. If this idea is true, then our own Big Bang might not have been a singular explosion from nothing. It may have been the moment when a star in another universe collapsed so deeply that its interior opened into a brand new cosmos, ours. In this view, the universe is not isolated. It is part of a larger family, a lineage of universes, each born from the collapse of stars in older universes. Black holes become cosmic wombs, each holding a new space-time within their horizons, and each new universe in turn forms stars of its own, which eventually collapse into black holes, giving birth to even more universes, a branching tree of reality. A cosmic ancestry stretching across dimensions, a quiet generational flow. This idea doesn't claim certainty, it simply follows the mathematics where they naturally lead. General relativity predicts that inside a black hole, space-time can expand. Quantum physics suggests that collapse might not lead to a final point, but to a transition into something new. And the observed smoothness of our universe, its uniform temperature, its consistent structure, hints that it may have been born from material compressed into extreme density, just like the interior of a collapsing star. Even the properties our universe carries, its total mass, its possible angular momentum, are exactly the traits black holes preserve. A black hole erases complexity but keeps two simple things, mass and spin, and our universe has both. If we were born inside a black hole, that would explain why our universe began so dense, so hot, so uniform. It would explain why space expanded faster than light in its first fraction of a second. It would explain why the cosmic horizon has a size that matches the event horizon a black hole of our mass would have. All of it becomes less mysterious, not solved, but softened, when seen through this gentle lens. As you breathe slowly, imagine the universe as a newborn interior, the spacious inner life of a star that collapsed long ago. A place where the fall inward became an expansion outward, where endings transformed into beginnings, where gravity's deepest curve opened into a cosmos filled with galaxies and light. You, right now, may be living inside the quiet result of that transformation. To understand the earliest moments of our universe, we often hear the phrase cosmic inflation. It refers to an event so sudden, so vast, and so far beyond ordinary imagination that even calling it an explosion feels small. Inflation was not a burst of matter spreading outward. It was space itself stretching, smooth, uniform, silent. In a fraction of a second, the universe expanded faster than light could ever hope to travel, growing from subatomic size to cosmic scale before the first breath could be taken. For decades, inflation has been described as an independent process, a strange feature of the universe added to make the equations work. But when we consider the idea that our universe might be the interior of a black hole, something interesting happens. Inflation stops looking like a complication and begins to look like a natural consequence. Imagine the interior of a collapsing star. As matter falls inward and space-time curves more deeply, the central region becomes a place of incredible pressure and density. At some moment, perhaps the moment we associate with our Big Bang, the interior geometry stops collapsing and begins expanding in a new direction. The inward fall transforms into outward growth. The collapse gives rise to a fresh dimension of time. Inside a black hole, this expansion could be immense, smooth, uniform, fast beyond comprehension. A sudden stretching of space-time, exactly what we call cosmic inflation. In this view, inflation isn't something added to cosmology, it is something inherited. A natural property of a new space-time emerging inside a gravitational collapse. To imagine this gently, picture a balloon being pressed so tightly that its surface crumples inward. But at some point, the pressure inside forces a new surface to appear, a growing interior stretching out in all directions. The balloon doesn't explode, it unfolds, smoothly, silently. The interior becomes its own spacious world. This unfolding is what inflation might have been. It explains why our universe looks so uniform across vast distances. It explains why the temperature of the cosmic microwave background is almost perfectly even. It explains why space expanded faster than light. Because it wasn't matter moving through space, it was space opening up, making room for everything that would one day form stars, galaxies, planets, and life. Inside a black hole, the same kind of rapid expansion is predicted by the mathematics of general relativity. The collapse of matter compresses space-time until the only direction left is outward, not outward into the parent universe, but outward into a new interior. A universe inside universe. A horizon within a horizon. If this idea is true, then cosmic inflation was not a mysterious burst from nowhere. It was the natural beginning of a new cosmos gently unfolding from the collapse of something older. A transformation written into the geometry of space-time itself. As you breathe softly, imagine that first instant, not as a violent explosion, but as the quiet opening of a door, a silent bloom in the dark. The moment a hidden interior began to awaken, stretching outward at speeds beyond imagination, forming the cosmic stage on which everything you have ever known would eventually appear. Inflation is not just a scientific theory. It may be the first breath of a universe born from collapse. A breath that still echoes in the expansion we see today. A breath you are living inside right now. The word singularity often conjures images of a violent, impossible point. A place where everything breaks down, where physics collapses, where matter is crushed into nothing. In popular imagination, it is the most frightening part of a black hole, the endpoint of all falling paths, the end of any story unlucky enough to cross its horizon. But the deeper we listen to the mathematics, the quieter the singularity becomes. Not an explosion, not a tear, not a void, but a limit, a boundary in our understanding, not necessarily a boundary in nature. The singularity is not the universe collapsing. It is our equations collapsing. A signpost telling us that space-time is bending in ways our current tools cannot fully describe. To reimagine the singularity, breathe gently and picture not a point of destruction, but a place where new geometry emerges. A place where the inward fall of matter transitions into something unfamiliar. A new direction, a new region, a new way for space-time to unfold. General relativity does not say the singularity must be a point. It says only that our normal coordinates fail there, that space-time becomes so curved our usual concepts stop working. But new physics, quantum gravity, loop gravity, string theoretic models suggest something more hopeful. The singularity might be a bridge, a doorway, a boundary where one universe gives way to another. This is where the black hole universe hypothesis finds some of its calmest beauty. When a massive star collapses, its matter compresses inward until space-time can no longer contract in the same familiar direction. At that boundary, what we call the singularity, the geometry may bounce, opening into a new expanding region. That expansion could look to its inhabitants exactly like a Big Bang. From their perspective, the singularity isn't behind them as a point. It is behind them as a moment, a transition, the instant the universe began to stretch and grow, the first breath of cosmic expansion. To imagine this, picture standing inside a vast empty dome. You walk toward the deepest part of the floor, the point where the curve gathers everything inward. But as you reach it, the structure suddenly inverts. The inward curve becomes an outward one. The hollow becomes a bubble, growing away from its centre. You're not crushed. You are carried into an expanding interior. This is one of the ideas that quietly animates modern cosmology. Maybe the singularity that began our universe was not a point of infinite density. Maybe it was the moment when the interior of a collapsing star flipped into a new space-time, a new outward direction disguised as the first instant of time. Even the familiar questions soften when seen through this lens. Why was the early universe so hot? Because collapse gathers energy. Why was it so smooth? Because everything began from an incredibly compressed state. Why did expansion begin so quickly? Because the interior was opening under extreme curvature. Each feature of the early universe becomes less mysterious when reimagined as the interior of a collapse, rather than the creation of something from nothing. The singularity, then, is not a disaster. It is an invitation, a moment where physics hints at a new structure, a new space-time, a new universe waiting quietly on the other side of collapse. As you breathe slowly, imagine that moment not as fear, but as transformation. The silent turning point where one cosmos ends and another begins. When we look out into the night sky, the universe feels endless. Galaxies drift on horizons of faint light, space stretches in every direction, and our telescopes reveal more structure the deeper we peer. But beneath this sense of vast openness lies a quieter truth. Our universe is sealed off, not with walls, not with barriers, but with time itself. There is a boundary beyond which we cannot see, cannot measure, cannot gather information, a soft cosmic horizon that wraps around us like the inside of a sphere. This boundary is not physical, no membrane, no shell, no surface. It is simply the distance that light has been able to travel since the universe began. Everything beyond that is hidden, not because it is unreachable, but because its light has not yet arrived. In this way, our universe has an edge defined not by space, but by age. Cosmologists call this the observable universe, and it is only a portion of the whole. Beyond it lies more, perhaps an infinite expanse, but to us, it is sealed away by the speed of light and the short lifetime of the cosmos. This horizon behaves in a way that feels strangely familiar. It mirrors, in many ways, the boundary surrounding a black hole. Think of the event horizon again. the surface beyond which no information can escape. Once crossed, signals cannot return, no matter how desperately they try. To an observer outside, the interior becomes permanently hidden. Now look again at our own cosmic horizon. Anything beyond it cannot send a signal to us. Not because gravity pulls inward, but because space itself expands faster than light can travel back. Light from beyond the horizon is forever outpaced by the growth of the universe. It falls behind, trapped not by gravity, but by time. Two horizons, two boundaries, two regions sealed by different mechanisms, but with effects that echo each other in eerie ways. This resemblance becomes even more intriguing when we consider size. When physicists calculate the radius of a black hole that would contain the same mass as our universe, the radius they derive is the same as the radius of our observable cosmos, almost exactly. This is the first soft hint that our universe might be an interior, a region bounded by a horizon that behaves mathematically like the boundary of a black hole. But there is another layer to this sealed-off feeling, the expansion of space. As the universe stretches, distant galaxies drift away not because they move, but because space grows between us and them. Some galaxies recede faster than the speed of light. They are not breaking physics, they are obeying it. In an expanding space-time, recession speed is not limited by the rules of motion. These galaxies drift beyond our horizon. Once they cross, they can never return. Their light will never reach us again. We see them now only because their ancient light, emitted billions of years ago, is still catching up to us, like whispers travelling through fog. In time, even familiar galaxies will slip beyond this horizon. The universe will grow emptier, quieter, more sealed off with each passing epoch. And yet from inside it all feels normal. The stars still shine, the galaxies still spin, the night sky still opens like a vast window. But maybe it isn't a window at all. Maybe it is the inner surface of a larger horizon. Maybe the universe behaves as if it is inside a black hole, because it is inside one, an interior region we can never escape, because escaping would require outrunning the very expansion of space-time. As you breathe gently, imagine the universe not as boundless openness, but as a spacious room whose walls are made of time, widening softly but forever sealing us within. A room large enough to hold every galaxy, every star, every moment you have ever known, yet still only a fraction of a greater reality outside. There is a quiet allure to the idea that black holes might be more than endings, more than silent traps in space, more than regions where matter vanishes into darkness. For decades, physicists have wondered whether black holes could act as gateways, openings into new regions of space-time, pathways through dimensions we cannot yet perceive, bridges from one universe to another. This doesn't mean tunnels we could travel through, or doors we could walk into. It means something gentler, deeper, that the interior of a black hole might not be a dead end, but a transition. Imagine space-time as a vast fabric, smooth and stretching in every direction. A black hole is a place where this fabric folds, curves, and dives inward like a deep funnel. But at the very bottom of that funnel, where our classical understanding ends, the mathematics of general relativity reveals something unexpected. Instead of collapsing all paths to a point, the equations suggest that space-time may open up again, into a new region, a new interior, a new branch of reality. This is where the idea of black holes as cosmic gateways begins. Not passages we can enter and leave at will, but birthplaces of new expanses of space-time. Gateways in the sense that a seed is a gateway to a forest, or a womb is a gateway to a life. Physicists describe this interior unfolding with careful language. They speak of maximal extensions of space-time, of new coordinates that appear only once old ones break down, of regions that exist beyond horizons. These are not science fiction fantasies. They are mathematical consequences of Einstein's equations. In some solutions, the interior of a black hole connects to another universe entirely. In others, it leads to a white hole, a theoretical region where matter can only emerge, never fall in. In still others, the singularity is replaced by a bounce, a transition that redirects the collapsing interior into outward expansion. Through each of these interpretations, the message is the same. Black holes may not be final. They may be doorways into something new. This is especially compelling when we consider that black holes preserve only two properties from everything that falls in: total mass and total angular momentum. Complexity disappears, details vanish, but these two fundamental traits remain and shape the interior. If a black hole becomes a new universe, then its mass determines the energy of that universe's birth, and its angular momentum becomes the spin of the new cosmic interior. These are exactly the large-scale properties we observe in our own cosmos. And then there is the elegance of scale. When we calculate the size of a black hole that would contain the mass of our universe, the radius of its event horizon matches the radius of our observable cosmos, a soft symmetry, a whisper of correspondence. Add to this the quiet intrigue of cosmic rotation, the observation that many galaxies appear to twist in a preferred direction, and the idea begins to form a gentle, coherent narrative. Black holes may be gateways, and our universe may be what lies on the other side, not a tunnel, not a portal, but a transformation. A region where space-time extends, grows, and becomes the vast expanse we see today. As you breathe slowly, imagine the universe as the quiet interior of a cosmic gateway, a place where all paths once converged, and then opened into a new and expanding horizon, a place where collapse turned into creation, a place you drift within, carried gently by the flow of space-time itself. Time is something we often treat as steady, a quiet river flowing at the same pace everywhere, guiding our days, our breaths, our lives. But in the presence of gravity, time becomes softer, more flexible, more willing to stretch and bend. The deeper you fall into a gravitational well, the slower time flows for you compared to someone far away. This isn't a theory or a poetic metaphor. It is one of the most precise, experimentally confirmed truths in physics. Atomic clocks placed on the top floor of a building tick faster than those on the ground floor. Clocks orbiting Earth on GPS satellites tick faster than those here on the surface. The deeper you are in gravity, the more gently time moves, and a black hole, a region of extreme curvature, is the most profound example of this. Imagine floating near the event horizon of a black hole. From your own perspective, your seconds feel normal, calm, steady, familiar. You think a thought, you breathe a breath, you move a hand. Everything is as it has always been. But to a distant observer watching you through a telescope, your time slows, your movements stretch, your voice deepens into silence. Light leaving your body becomes redder, softer, dimmer, until it fades entirely. Two truths, equally real. Two flows of time, shaped by where you stand in the geometry of space-time. Now imagine stepping across the horizon. Inside, something extraordinary happens. The inward direction, the place where space once pointed, becomes the future. You cannot choose to move outward, because outward is no longer a direction time allows. Your fall becomes a timeline. Your inward journey becomes the only path forward. This is where the black hole cosmology idea becomes deeply compelling. If time behaves differently in strong gravity, and if a black hole's interior creates a new direction for time to flow, then the birth of a universe inside a black hole becomes not only plausible, but natural. Inside such an interior, time would not resemble the time of the outside universe. It would begin at the moment of transition, what we call the Big Bang, and then flow outward through expansion. The curvature that once guided matter inward would turn into the curvature that guides matter outward. From within, all you would see is a universe with a beginning, a timeline pointing forever forward, and a horizon marking the limit of what you can observe. This is exactly what we experience. We live in a cosmos where time began in a hot, dense state, where space expands smoothly in every direction, where the further we look, the more we peer back through earlier moments, where the cosmic microwave background glows with a uniform warmth, whispering of a moment when everything was compressed into extreme curvature. In a black hole interior, this behavior is precisely what the equations predict. A new timeline unfolding outward, a new geometry expanding, a new universe growing from the seed of collapse. Even the acceleration of cosmic expansion, the mysterious dark energy, can be seen as a natural consequence of interior geometry, stretching under gravitational influence. So breathe softly and imagine this. Time, inside our universe, may be shaped by the very same curvature that shapes time near a black hole. Your seconds, your heartbeat, your life, all unfolding along a timeline that may have begun deep within the gravitational well of another cosmos. Not as a prison, but as a cradle, a place where time flows gently, naturally forward, guiding stars, galaxies, and you through an expanding interior. When we look at the universe on its larger scales, something remarkable emerges. Everywhere we look, things are almost the same. The temperature of the cosmic microwave background, the afterglow of the early universe, is nearly identical in every direction. Galaxies cluster in patterns that repeat across vast distances. Space appears smooth, balanced, and astonishingly uniform, as though the cosmos were shaped in a single breath. To cosmologists, this uniformity is both comforting and mysterious. Comforting because it suggests the universe began in a state of extraordinary symmetry. Mysterious because distant regions of space are so far apart that they could never have interacted, never shared information, never exchanged heat. There simply hasn't been enough time for light, or anything else just to travel between them, and yet they match. They match with uncanny precision. As if the universe were once packed so tightly together that everything touched everything else. As if all of space emerged from a single compressed seed. This is where the black hole universe idea casts a gentle, illuminating light. Imagine the interior of a collapsing star, a region squeezed into unimaginable density. Matter drawn inward until it becomes nearly uniform. Temperature rising until it becomes nearly equal everywhere. Curvature increasing until all directions behave the same. When such a region opens into a new space-time, when it blossoms into what we experience as a universe, it would naturally produce the kind of uniformity we observe today. The early universe should be smooth, because it began from the compressed interior of collapse. Cosmic inflation also helps explain this smoothness. In the first fraction of a second after the Big Bang, the universe expanded faster than the speed of light, stretching any tiny irregularities into a near-perfect uniformity. But inflation too may itself be a natural feature of a black hole interior, the rapid expansion triggered by extreme curvature and density. Together, collapse and expansion form a story that flows effortlessly. A star collapses. Its interior becomes a compressed uniform region. That region opens into a new space-time and expands rapidly, preserving the smoothness of its origin. In this view, the uniformity of the universe is not just an observation, it is a fingerprint, a mark of the conditions within a massive gravitational collapse. Even the cosmic microwave background supports this idea. Its faint 2.7 Kelvin glow is so incredibly even that only a single physical scenario can produce it. A state where the universe was once small enough, dense enough, and hot enough for all of space to share the same temperature. This shared temperature is difficult to explain if the universe always existed in its vast, stretched-out form, but it becomes simple, almost inevitable. if the universe was once an interior space smaller than an atom, a place where matter and light were pressed together under immense gravity before expanding outward. Think of the universe as a breath drawn from a single point, then stretched across billions of years. Every direction carries traces of that first unified moment, a moment we glimpse when we study the microwave background, when we measure galaxy distributions, when we map the quiet symmetry of the cosmos. As you breathe slowly now, imagine that smoothness as a memory, a cosmic imprint left by the collapse that may have birthed our universe, a whisper from the moment everything was one, before space unfolded into the gentle vastness we drift through today. Everything in the universe spins. Planets spin, stars spin, galaxies swirl like cosmic spirals. Even the smallest particles carry angular momentum. Spin seems woven into the fabric of existence, a quiet, universal dance that repeats across every scale. Black holes are no exception. In fact, they may spin more beautifully, more profoundly than anything else in the cosmos. A rotating black hole drags space-time around with it, twisting the very fabric of reality into a whirlpool of geometry. This rotation is not decorative. It shapes the black hole's horizon, its interior, and the structure of space-time that blooms within. To understand why this matters for our universe, let's begin with something simple. Imagine a figure skater gliding across ice, arms outstretched. As the skater pulls their arms inward, they spin faster. This is the conservation of angular momentum, the principle that when an object becomes smaller, its rotation speeds up to preserve its total spin. Gas clouds behave the same way. As they collapse to form stars or planets, any tiny imbalance in motion is amplified, causing the final object to spin. Now, imagine something collapsing on a cosmic scale, a massive star forming a black hole. As its radius shrinks, even the slightest rotation becomes enormous. The resulting black hole can spin at extraordinary speeds, dragging space-time into a deep, swirling curve. This spin has consequences. It expands the black hole's horizon. It shapes its interior. It determines the geometry of any new space-time that might unfold inside. It becomes one of the only two pieces of information a black hole truly preserves: mass and angular momentum. And this leads us to a quiet, intriguing possibility. If our universe came from the interior of a black hole, then the black hole's spin would have been inherited by the newborn cosmos. This might help explain one of the strangest hints in modern astronomy, the suggestion that our universe may have a net rotation. A recent analysis of galaxy spins found something unexpected. When astronomers studied hundreds of spiral galaxies above and below the plane of the Milky Way, they found that about 2/3 rotated in the opposite direction from our own. Not a perfect alignment, not fully conclusive, but more than random chance would suggest. In a universe where galaxies should form with random orientations, like leaves scattered by wind, this subtle preference is surprising. If true, it means the universe may carry a slight twist, a large-scale angular momentum inherited from somewhere deeper. And where could that spin have come from? Not from a big bang that erupted symmetrically in all directions, not from random turbulence in the early universe, but from something spinning before the Big Bang. Perhaps the rotating black hole, whose interior became our cosmos. In this view, the spin of galaxies is not an accident. It is a memory, a gentle echo of a collapsing star's final rotation. If the black hole that birthed our universe was spinning, and most black holes do, then our cosmos would naturally inherit that twist. It would be imprinted across billions of light years, subtle but detectable, shaping how galaxies rotate, how cosmic structures form, how space-time curves across the larger scales. As you breathe softly, hold this image, a vast universe turning ever so slightly, carrying the echo of a spin that began long before time itself. A rotation not of chaos, but of origin. A quiet twist passed down across cosmic generations, whispered into the structure of galaxies and into the very fabric of the night. At the smooth scale of planets and stars, space-time feels like a calm, continuous fabric. But when we drift down to the smallest possible scales, far smaller than atoms, smaller even than particles, the calmness dissolves. Space-time becomes restless, uneven, flickering, foam-like. Physicists call this seething foundation quantum foam, a name as soft and poetic as the phenomenon it describes. At these microscopic scales, empty space is not empty at all. It boils with fluctuations, particles appearing and vanishing, fields rising and falling, tiny bubbles of space-time forming and dissolving in impossibly small moments. This foam is the deepest layer of reality we currently imagine, a jittering, shimmering sea from which both particles and geometry seem to arise. Now imagine what happens to this foam near the edge of a black hole. The event horizon is not merely a gravitational boundary. It is a place where the classical world and the quantum world collide. Gravity curves space-time so deeply that quantum fluctuations become magnified. The foam becomes more turbulent, more energetic, more significant. According to some theories, the horizon of a black hole is where the quantum character of space-time reveals itself most vividly. Particles appear in pairs, with one falling inward and the other escaping, a process Hawking famously showed leads to black hole evaporation. The horizon becomes a simmering surface, alive with information, fluctuations, and tiny exchanges of energy. Now place this idea beside the possibility that our universe has a horizon too. A cosmic horizon defined not by gravity, but by the limits of time. A boundary where information from beyond cannot reach us. A place where space-time stretches faster than light can cross. What if this horizon too interacts with quantum foam? In the black hole universe perspective, the cosmic horizon functions much like an event horizon, a surface where quantum fields, vacuum fluctuations and information behave in complex, deeply fundamental ways. Some cosmologists propose that dark energy, the mysterious pressure accelerating the expansion of the universe, might arise from these quantum fluctuations at the cosmic horizon, much like Hawking radiation arises at a black hole's horizon. In other words, the bubbling at the edge of space-time might not only be microscopic, it might be cosmic. This idea offers a soft, intriguing symmetry. At the boundary of a black hole, quantum foam shapes the horizon. At the boundary of our universe, quantum foam may shape cosmic expansion. Both horizons store and emit information. Both boundaries act like surfaces where space-time itself becomes active. This symmetry grows deeper when we remember that a black hole's interior may become a new universe. If our universe began as the interior of a collapsing star, then quantum foam near the parent black hole's horizon might have influenced the properties of the universe that formed inside. Tiny fluctuations could have become the seeds of galaxies, stars, and clusters, ripples magnified by inflation into the structure of the modern cosmos. Those faint temperature variations in the cosmic microwave background, the ones that tell us where galaxies would eventually form, may be echoes of quantum fluctuations from a time before our universe even had space to hold them. Fluctuations born at or near a horizon, fluctuations shaped by gravity and quantum foam. As you breathe gently, imagine the universe not as a smooth fabric, but as a soft, shimmering surface resting atop a deeper, bubbling ocean of uncertainty, a place where the smallest fluctuations ripple out into galaxies, where the quantum and the cosmic meet at horizons, where creation begins with tiny tremors of space-time itself. In physics, information doesn't mean words written on a page or memories stored in a mind. It means the fundamental details about the state of things, the arrangement of particles, the energy they hold, the way they move, the identity they carry. Information is the quiet blueprint of reality, and one of the deepest principles in modern physics is this: information cannot be destroyed. It can change, flow, or rearrange, but it cannot vanish. This principle becomes especially important at the edge of a black hole. For decades, scientists believed that anything falling into a black hole would disappear forever. Matter, light, particles, energy, all pulled inward, all lost beyond the event horizon. But this idea created a puzzle, a paradox. If information truly vanished inside a black hole, then quantum mechanics, the framework governing the smallest scales, would be broken. The universe, it seems, does not allow that. And so came one of the most elegant ideas in theoretical physics. Information is stored at the horizon, not in the interior, not in the singularity, but on the surface, the thin boundary surrounding the black hole. This idea led to the holographic principle, the realization that everything happening inside a region of space can be encoded on its boundary. Like a cosmic hologram, the three-dimensional world is mirrored on a two-dimensional surface. Now, let's place this insight beside our own universe. We too have a boundary, the cosmic horizon. Not a physical surface, yet still a limit beyond which information cannot reach us. As the universe expands, galaxies drift beyond this boundary, taking their light and history with them. Once they cross, their information is inaccessible forever. So a gentle question arises: is our universe holographic too? Could all the information inside the cosmos be encoded on its horizon, the same way information inside a black hole is encoded on its event horizon? Some cosmologists believe the answer is yes. They propose that the structure of the universe, the distribution of galaxies, the flow of time, the expansion of space, may be governed by information stored on the cosmic boundary. In this view, the entire universe behaves like the interior of a black hole, following the same principles of information conservation. Another layer emerges when we recall that a black hole preserves only two large-scale properties from everything that falls in: the total mass and the total angular momentum. Everything else becomes part of a holographic imprint on the horizon. Intriguingly, our universe displays exactly these large-scale features: a total mass-energy content, and potentially a faint large-scale rotation. Both could be inherited from a parent black hole, stored at the horizon, and carried into the new space-time that formed inside. Information, it seems, does not vanish. It simply changes form, hidden on boundaries, encoded in horizons, woven into the structure of reality. If our universe is indeed inside a black hole, then the cosmic horizon we see is not only a limit, it may also be a keeper of memory, a surface that encodes the story of everything within, every galaxy, every star, every moment. As you breathe gently, imagine the universe not as a volume but as a reflection, a hologram projected from its own horizon, a quiet reminder that information flows even when light cannot, that boundaries hold more than emptiness, and that the universe remembers its origins in ways too subtle for our eyes, but not too subtle for the fabric of space-time itself. Light is our messenger. It is the thread that connects us to the farthest galaxies, the silent traveller that reveals the age, shape, and story of the cosmos. Every image we have of the universe, every nebula, every star cluster, every spiral of distant galaxies is carried to us by light that has journeyed across billions of years. And yet, even light has its limits. Near a black hole, light begins to struggle. It bends, slows, reddens. Not because it loses energy in the usual sense, but because space-time curves so deeply that the path outward becomes longer and longer. A photon leaving the surface of a collapsing star must climb up an ever-steepening gravitational hill. Each step upward stretches its wavelength, red, then redder, then invisible. The closer light begins to the horizon, the harder its journey becomes. Some photons escape, Some linger, some circle the black hole in fragile spiraling orbits, and some never make it out at all, trapped not by a force, but by geometry. This bending of light is one of the essential fingerprints of gravity. Einstein predicted it long ago, and astronomers have observed it countless times. Light is deflected around stars, it arcs around galaxies, it stretches across clusters, it drapes itself over space-time like a flowing silk ribbon, following the curves beneath it. But nowhere is this bending more profound than near a black hole. From the outside we see a region where light cannot escape, a perfect darkness. From the inside, an entirely different story may unfold. Light falling inward follows the natural flow of space-time, drifting toward the centre. There is no awareness of imprisonment. Photons simply travel where geometry guides them. Now imagine placing this behaviour beside the universe itself. The cosmic microwave background, the faint afterglow of the early universe, is light that has been struggling to reach us for 13.8 billion years. It has been stretched by expansion into microwaves, cooled into a whisper. What was once a bright, hot blaze has become the most delicate signal in the night, a soft glow that fills the cosmos with quiet, uniform warmth. Like light near a black hole, this radiation carries the imprint of extreme gravity and early compression. It is red-shifted not by collapse, but by expansion, the inverse process, yet spiritually similar. Both effects stretch light, both soften it, both push it toward invisibility. This parallel grows deeper when we consider that the universe may be an interior, a place where space-time expanded rapidly after collapse. In such a scenario, the ancient light we observe could be the fading afterglow of the moment when the interior opened into a new region. The microwave background becomes a memory, a relic of the transition that gave rise to everything we see. And just as light near a black hole tells us about its behaviour, the microwave background tells us about the geometry of our universe, its smoothness, its faint ripples, its nearly perfect uniformity. All are signatures of a space-time that may have begun not in emptiness, but in extreme curvature. Light, always our messenger, continues to reveal these secrets. Its struggle to escape a black hole mirrors its struggle to reach us from the dawn of time. Both are journeys shaped by geometry, one by collapse, the other by expansion. As you breathe softly, imagine the universe as a place where light is forever travelling, forever stretching, forever whispering the story of its origins. A place where every photon carries a memory of beginnings, whether from the heart of a star or from the first moments of a cosmos that may itself be the interior of something deeper. If the universe could keep a diary, a record of its earliest moments, that diary would be written in light, not in words, not in symbols, but in a faint ancient glow that fills all of space with quiet uniformity. This glow is the cosmic microwave background, the oldest light we can see, the afterglow of the moment the cosmos first became transparent. It is not bright, it is not sharp or dramatic, it is a whisper, a soft, even hum of radiation stretched across the entire sky, arriving from every direction with almost perfect equality. This gentle uniformity is one of the great mysteries of cosmology. How could regions so far apart, so unreachable to one another, carry the same temperature? How could the universe be so smooth when distant areas never had time to exchange light or heat? In the standard view, the answer lies in cosmic inflation, a burst of rapid expansion that stretched a once tightly connected universe into enormous scale. But if our universe began inside a black hole, this smoothness becomes something deeper, something inherited. Imagine the interior of a collapsing star just before a black hole forms. Matter is packed so tightly that every region interacts with every other. Temperatures equalize, energies blend. The star becomes a near-uniform sphere of extreme density. If this interior then opens into a new space-time, if a universe blooms inside, the newborn cosmos would naturally begin smooth, balanced, deeply uniform. Then expansion would stretch that uniformity outward, freezing it into the cosmic background radiation we see today. In this sense, the microwave background is not just a fossil of the early universe, it is a memory of the collapse that may have birthed our world, a whisper from the last moments of the parent star's life, preserved and softened by cosmic expansion. We can see this memory in the map of the microwave background. Small temperature variations marking where galaxies would one day form, wide uniform regions hinting at the compressed interior from which everything emerged, faint ripples revealing the seeds of cosmic structure. These variations are tiny, only one part in 100,000, yet they are the blueprint of everything that exists, every cluster of galaxies, every filament of cosmic web, every star, planet and living being. All of it emerged from those slight irregularities that may have been quantum fluctuations magnified by inflation, or echoes of turbulence inside the collapsing star that created us. The microwave background is like the universe's first photograph, a portrait taken when it was just 380,000 years old, an infant wrapped in a uniform glow, still carrying the warmth of its beginning. And this warmth reveals something else. It is not just light, it is red shifted light, stretched by billions of years of expansion. Just as photons struggle to escape a black hole, losing energy and stretching into longer wavelengths, the early light of our universe has been pulled into microwave frequencies, a soft symmetry between collapse and expansion. Between the behaviour of light near black holes and the behaviour of light in our universe. As you breathe gently, imagine this glow as the universe remembering where it came from, a cosmic lullaby carried across billions of years, a reminder that even the vastness around us began as a dense, warm interior, perhaps one that existed inside a larger gravitational story. The microwave background is not just ancient light, it is the quiet echo of creation, a memory written in photons, a message from the moment before space became the spacious universe we drift through tonight. Gravity is the architect of the universe. It shapes galaxies, sculpts stars, binds planets, and guides the motion of everything that drifts through space. And yet, when we look around at our own universe, something feels surprisingly delicate. Gravity here is gentle, almost whisper-soft compared to the violent gravitational depths inside black holes. The gravitational pull between you and the Earth keeps your feet on the ground. But compared to the forces shaping black holes, it is faint, fragile, tender. This gentleness has always puzzled physicists. Why is gravity so weak compared to the other forces? Why can a simple refrigerator magnet overpower the entire Earth's gravity on a paperclip? Why does the universe expand so easily, so freely, with gravity offering only the lightest restraint? If our universe were born inside a black hole, this softness begins to make sense. Imagine the interior of a black hole, a region where space-time curves inward with tremendous intensity. Near the singularity, gravity becomes unimaginably strong, but in the black hole cosmology picture, that singular region is not the space we inhabit. It is the transitional moment, the instant of rebirth, before the interior opens into a new expanding space-time. As the newborn universe expands, its density drops rapidly. The more it expands, the more diluted its matter becomes. The gentler gravity grows. If our universe began as an interior region inside a black hole, then the fierce gravitational curvature that created the singularity would have softened into a vast, expanding cosmos where the gravitational field becomes weaker with distance. The intense curvature doesn't follow us into our universe. It stays confined to the moment of the Big Bang. This is why gravity feels so soft here, because we are living far from the source of the curvature that created us, far out in the expanding interior where space is stretched into near flatness. There is another layer to this gentle gravity. Black holes obey simple scaling laws. The bigger a black hole is, the weaker the gravity feels inside its horizon. A stellar mass black hole has fierce tidal forces, enough to tear matter apart. But inside a supermassive black hole, the tidal forces at the horizon are mild. You could fall in without noticing anything at all. And if there were a black hole massive enough to contain an entire universe, the interior space-time would be incredibly smooth, flat, wide, gentle. The gravity inside such an enormous interior would be almost imperceptible, just like the gravity in our cosmos. A universe inside an unimaginably large black hole would feel exactly as ours does, expanding smoothly, stretching effortlessly, governed by gravity too weak to prevent galaxies from drifting apart. This is not proof. It is a pattern. The soft harmony between what gravity looks like inside a massive black hole and what gravity feels like across the vastness of our cosmos. Even the accelerating expansion of the universe, something attributed to dark energy, can be reinterpreted in this picture. As the interior of a rotating massive black hole grows, the geometry itself may force expansion to accelerate naturally. Gravity becomes not a force binding the universe inward, but a curvature encouraging it outward. So breathe slowly and imagine this. Our universe is gentle because we are living in the wide, stretched interior of something immense, an interior so large that the gravitational forces once present have faded into a soft, almost imperceptible pull. Gravity here is quiet, not because the universe is empty, but because it has grown vast enough to cradle you in a space where forces settle into calmness, the peaceful afterglow of a cosmic birth. When we look out into the night sky, we see a universe that is not still. It is stretching, flowing, expanding in every direction, carrying galaxies farther and farther apart as time drifts forward. This expansion is one of the most extraordinary discoveries in all of science, the realization that space itself is growing, not simply that objects are moving within it. Yet even more mysterious is this: the expansion is accelerating. The universe is not only growing, it is growing faster with each passing moment. Physicists call the unknown cause of this acceleration dark energy, a name chosen not because it describes what the force is, but because we understand so little about it. But if our universe is the interior of a black hole, this acceleration might not be mysterious at all. It might be natural. Imagine the interior of a black hole forming. As matter falls inward, space-time curves more and more deeply until a new region begins to open. This interior doesn't stay static. In many models of general relativity, once the interior turns outward, it begins to expand, and not slowly but rapidly, driven by the same curvature that created it. Now think of a black hole not as a small object, but as something enormous, a parent universe collapsing into a star-sized object in its own space-time. Inside that black hole, the new interior could grow to a tremendous size. As the parent black hole gains more mass, its interior volume could expand as well. This leads to a quiet but profound idea. The acceleration of our universe may be connected to the growth of the black hole we live inside. If the parent universe continues to feed the black hole, stars falling in, gas swirling inward, entire galaxies consumed, the mass of the black hole increases, and when the mass increases, the black hole's horizon grows. If a new universe exists inside, that interior may grow with it, naturally accelerating the expansion of its own space-time. In this view, dark energy is not a mysterious pressure or force. It is simply geometry, the same curvature that shapes the interior of a rotating, ever-growing black hole. This idea aligns beautifully with the way large black holes behave. The bigger the black hole, the larger its interior volume becomes. This interior volume can grow faster than the horizon itself, a behavior that matches our universe's acceleration almost perfectly. Even the shape of expansion echoes black hole geometry. Galaxies farther away from us recede faster than closer ones, not because they are being pushed, but because they inhabit regions of space-time that are expanding more quickly. It is the same kind of pattern found in certain black hole solutions, where the interior stretches non-uniformly with distance. Imagine this expansion not as a force driving galaxies apart, but as the natural unfolding of the space-time we inhabit, the gentle stretching of our cosmic interior as the black hole outside gathers mass and rotates through its own older universe. This perspective brings a surprising calm. Instead of dark energy as a mysterious, unexplained phenomenon, we see the acceleration as the natural continuation of the process that began at the Big Bang, the geometry of a newborn universe unfolding inside the collapse of something ancient. As you breathe softly, imagine the cosmos expanding like a slow inhale, a quiet breath taken by a universe growing from the inside out, every galaxy drifting farther apart, every star carried gently outward, every moment marking the natural blossoming of an interior space-time that may still be widening beneath our feet. Dark energy is one of the most mysterious concepts in modern cosmology. It has no color, no texture, no temperature. We cannot hold it, feel it, or see it directly. Yet its influence shapes the fate of everything, pushing galaxies apart, accelerating the expansion of space, guiding the long-term future of the cosmos with a hand so gentle it remained unnoticed for billions of years. But what if dark energy is not a thing at all? What if it isn't a force or a field filling space, but a geometric effect, a quiet phenomenon arising from the very horizon of our universe? Let's drift slowly into this idea. Imagine standing inside a vast, expanding sphere. At the edge of your vision lies the cosmic horizon, the farthest distance light has travelled since the universe began. That horizon isn't a wall, it isn't solid or sharp. It's simply the boundary between what can reach us and what cannot. Yet even boundaries that are made of time can have physical effects. At the edge of a black hole, the event horizon influences the behaviour of quantum fields. Particles flicker in and out of existence, energy exchanges occur, information is stored. The horizon is not passive, it is active, alive with quantum interactions. Some physicists wonder whether our cosmic horizon behaves in a similar way. Quantum fields fill all of space. Even the vacuum hums with fluctuations, tiny vibrations of energy happening everywhere all the time. Near the cosmic horizon, these fluctuations are subtly altered by geometry. Some modes can reach us, some cannot. Some stretch with expansion, some freeze at the edge. And when billions of these tiny fluctuations accumulate across the entire horizon, their combined effect may appear as a constant outward pressure, a gentle push causing the universe to accelerate. Not a mysterious substance, not a new force, but a horizon effect, a natural outcome of quantum fluctuation shaped by the boundary of space-time. This idea becomes even more compelling when we think of the universe as a black hole interior. A black hole has two important features. It has a horizon, and the behavior of quantum fields near this horizon gives rise to real, measurable energy. If our universe has a horizon acting in the same way, dark energy could be the interior's version of these quantum horizon effects. From this perspective, dark energy is not foreign. It is not something added to the universe. It is something inherited, a natural consequence of being inside a space-time region with a horizon. There is a beautiful symmetry here. A black hole's horizon produces Hawking radiation. A universe's horizon may produce cosmic acceleration. Both arise from quantum foam interacting with boundaries. Both depend on geometry, not on new substances. And if our universe is inside a black hole, the geometry of that parent black hole may shape how our cosmic horizon behaves today. Its mass, its spin, and even its expansion could leave imprints on the interior space-time, imprints we interpret as dark energy. So breathe softly and imagine the universe not as a place filled with an unknown force, but as a place shaped by its own horizon, a boundary that gently guides expansion, subtly nudging galaxies apart with the quiet influence of quantum space-time. In this view, dark energy becomes a whisper from the edge of the cosmos, a message carried by geometry, reminding us that horizons are not empty and that even the boundaries of space can shape the future of everything within. When we look at how matter is arranged across the universe, a stunning pattern appears, a cosmic web stretching across billions of light years. Filaments of galaxies weave together like threads of starlight. Clusters form at nodes where the web thickens. Vast voids open like dark, silent valleys between glowing structures. This arrangement is not random. It follows deep rules, the rules of gravity, curvature, and expansion. And these rules resemble, in many quiet ways, the geometry found inside a black hole. Let's explore that gently. Inside a rotating black hole, space-time does not curve in simple ways. It twists, it stretches, it funnels matter inward along specific directions while allowing other directions to expand. The curvature is not symmetric. It has structure, shape, and orientation. Now consider our universe. Galaxies do not distribute themselves evenly like grains of sand. They follow invisible curves, drawn outward as the universe expands, drawn inward by gravity, drawn along pathways formed by the tiniest fluctuations from the early universe. These pathways create the cosmic web, a pattern remarkably similar to what emerges from complex gravitational flows. Here is where the black hole universe idea offers a soft, illuminating perspective. 1. Black hole interiors naturally create directional flow. In general relativity, the interior of a rotating black hole contains a preferred direction, a kind of cosmic twist imparted by the angular momentum of the collapse. This twist shapes how matter moves inside. It funnels motion along arcs and curves, creating structured flow lines. 2. Our universe shows hints of structured flow as well. Galaxies align along filaments. Clusters form at nodes of intersection. Matter follows deep gravitational channels carved during the earliest moments of expansion. 3. If our universe inherited a rotation from a parent black hole, it would create subtle directional properties in the way matter spreads across cosmic scales. Not enough to make the universe spin visibly like a wheel, but enough to leave soft imprints in the distribution of galaxies, the formation of clusters, and the alignment of structures. 4. Even the large voids make sense in this picture. As space-time expands unevenly, regions with slightly less matter stretch faster, becoming enormous empty bubbles, while denser regions pull together into filaments. This pattern mirrors the complex geometry inside a rotating black hole, where some interior directions expand quickly and others contract, a dynamic dance of curvature. Another layer of harmony appears when we look at simulations of the early universe. Tiny fluctuations, quantum tremors from the very beginning, grow into galaxies and clusters. These tremors could have been amplified by inflation, but they may also reflect the subtle, swirling geometry of the collapsing star that birthed us. Black hole does not create random chaos inside. Its interior has structure, its geometry has personality. And if this geometry shaped the first moments of our universe, it would naturally guide matter into the patterns we see today. There is a soft poetic symmetry here. A star collapses into a rotating black hole. Its interior space-time inherits the spin, curvature, and flow of that collapse. A new universe emerges inside, filled with matter, following those inherited gravitational paths. Billions of years later, we see that structure reflected in the cosmic web, the map of how galaxies arrange themselves across the heavens. As you breathe gently, imagine the stars above you not as scattered lights, but as particles flowing through a vast geometric shape, a shape written long before galaxies existed, perhaps written in the collapse of a star in another universe. We may be living inside a cosmic structure shaped by the geometry of a black hole, a universe whose matter moved into place along the quiet curves of inherited space-time. There is a quiet idea in theoretical physics that brings a sense of gentle inevitability to the cosmos, a possibility that feels less like speculation and more like a natural continuation of what black holes already seem to do. The idea is simple to say, yet vast when you follow it to its edges. What if every black hole creates a new universe inside it? Not metaphorically, not abstractly, but literally, a new expanding space-time blooming in the hidden interior of every black hole that forms. To drift into this idea, let's start with what we know. A black hole forms when a massive star collapses. Matter falls inward, compressed into an extreme state. Space-time curves more and more deeply. A horizon forms, sealing the interior from the outside world. From the outside, this looks like an ending, a disappearance, a collapse into darkness. But from the inside, according to the mathematics of general relativity, this collapse might not stop. It may transform. The inward fall may become a new expansion. The singularity may become a bridge, or a bounce, or a moment of transition where new space-time opens, stretching outward into a fresh universe. In this view, each black hole is not the grave of a star, but the birth of a cosmos. Our universe, then, might be one branch on a vast cosmic tree, a tree with roots in the interior of black holes, a tree where each collapsing star gives rise to new realities. This idea has a quiet harmony. 1. Black holes erase complexity. They preserve only two simple properties of everything that falls in: mass and angular momentum. These become the parameters of the universe inside. 2. Our universe displays these same global properties. It has a total mass energy content, and it may even have a faint large-scale rotation, a twist that could have been inherited from the black hole that birthed it. 3. Inflation fits naturally into this picture. The extreme curvature inside a newly formed black hole could create the rapid expansion we call cosmic inflation. 4. Uniformity is expected. The interior of a collapsing star becomes extremely smooth and dense, the perfect starting point for a uniform Big Bang. 5. The cosmic web and galaxy rotation patterns may carry the faint echoes of the geometry of the collapsing star. And then there is the simplicity of it all. Stars form, stars collapse, black holes appear. Inside those black holes, new universes might branch off. Inside those universes, stars form again, and the cycle repeats. A cosmic ecosystem, a multiverse of inheritance, a quiet generational flow of universes, each born from the collapse of stars in the one before. Not a chaos of random worlds, but a lineage where physical laws repeat, shaped by the properties of the collapsing parent. If this idea is true, then every black hole in our universe, every dark sphere sitting at the center of galaxies, every stellar remnant scattered among the stars may contain its own vast interior, a place with its own galaxies, its own physics, its own horizons. Perhaps beings in those universes look out at their night sky and wonder the same thing we're wondering tonight. Perhaps they, too, sense the faint echo of a collapse that occurred in a universe they can never see. As you breathe gently, imagine the cosmos as a branching tree, each black hole a seed, each seed a universe, each universe filled with stars that will one day collapse and create more seeds. An infinite cycle of birth and transformation. You are living in one branch of that tree, drifting through the leaves of a universe that may have grown from the quiet interior of a collapsing star in another reality. If every black hole births a new universe, then our own cosmos is not a lone creation. It is a descendant, the child of collapse, the offspring of a star that lived, burned, and finally folded inward in a universe we will never see. This idea reshapes everything we think about beginnings. The Big Bang becomes not a sudden explosion from nothing, but a transition, the moment our universe inherited its place in a long cosmic lineage. To drift gently into this thought, imagine a massive star in another universe. It shines for billions of years, converting hydrogen into helium, forging heavier and heavier elements in its heart. Eventually its fuel runs low. The delicate balance between outward pressure and inward gravity falters. The star collapses. Inside that collapse, space-time curves sharper and sharper until a black hole forms, complete with a horizon, a singular interior, and a future no observer outside can glimpse. But inside, the story continues. The collapse that seemed like an ending becomes a beginning. Space-time flips from inward fall to outward expansion. Energy bursts into existence. Temperature surges. Geometry stretches. Time takes its first breath. This expanding interior becomes our universe. We inherit the mass of the star that died to create us. We inherit the spin of the gas cloud that formed it. We inherit the smoothness of its final compressed interior. We inherit the quantum fluctuations stirring across its collapsing surface. We are not a random creation. We are shaped by the final state of a cosmic ancestor. If this is true, then the properties of our universe, the constants, the laws, the patterns, may be echoes of the parent universe's black hole. The values of gravity, the strength of fundamental forces, the distribution of matter, the potential rotation detected in galaxy spins, all may be traits passed down through collapse. Our own universe may pass those traits to its descendants. When stars collapse here, when black holes form in our galaxies, each one may contain its own new interior, its own version of space-time, its own set of laws derived from ours. A cosmic family tree emerges. Parent universe, star collapse, black hole formation. New universe, blooming inside stars forming within, their collapse forming new black holes. And so on, endlessly. Each generation inherits subtle properties from the last. Mass, spin, physical laws. Just as living organisms inherit traits from their parents. Some cosmologists even propose a form of cosmic natural selection. Universes that produce many massive stars create many black holes. Universes with more black holes create more descendants. Over time, universes that are good at making stars, and therefore black holes, become more common in the multiverse family tree. In this view, our universe may not only be a descendant, it may be a successful one, fine-tuned by ancestry to make stars efficiently, to generate black holes abundantly, to pass itself forward through cosmic generations. Even our own existence becomes part of this lineage. We live in a universe stable enough for galaxies to form, gentle enough for stars to shine for billions of years, and vast enough for life to wonder where it came from. And if we someday create black holes through advanced physics, or if black holes in our universe one day collapse into deeper interiors, we may become ancestors ourselves, our universe giving rise to another, carrying forward the laws and patterns that shaped us. As you breathe softly, imagine yourself as part of this cosmic genealogy, a resident of a universe born from a star's final moment, a descendant in a family tree that stretches beyond horizons we will never cross. You are living inside a cosmic inheritance, a universe with parents, ancestors, and perhaps countless descendants yet to come. If our universe truly bloomed inside a black hole, then somewhere in the vastness around us subtle clues should remain, quiet fingerprints of our cosmic origin. These signs would not be loud or obvious. They would not shout their presence across the sky. Instead, they would be gentle, like ripples in a still pond, barely visible unless we look with patience, sensitivity, and wonder. Tonight, let's drift through some of the signs scientists have searched for, not as proofs, not as declarations, but as soft possibilities guiding our curiosity. One of the first clues is the size of the observable universe. When physicists calculate how large a black hole would need to be to contain the mass of our cosmos, the result is striking. The radius of that black hole's event horizon matches the radius of the universe we see, almost exactly. This is not a coincidence necessarily, but it is certainly an invitation to look deeper. Another sign appears in the uniformity of the cosmic microwave background, the ancient light left over from the earliest moments of the universe. Its temperature is nearly identical everywhere, which is hard to explain unless everything was once incredibly compressed, just as matter becomes uniform inside a collapsing star. Tiny variations in that glow, the ones that eventually formed galaxies, could be echoes of turbulence inside the parent star, magnified as the universe expanded. Then there is the question of rotation. If our universe inherited angular momentum from the black hole it was born inside, if that cosmic ancestor spun as it collapsed, then our universe might carry a faint twist as well. Some studies have found hints of this. 2/3 of certain spiral galaxies appear to rotate in a preferred direction. Not perfectly, not conclusively, but enough to raise an eyebrow and perhaps a heartbeat. A rotating universe would not swirl like a whirlpool. Its rotation would be subtle, an almost imperceptible drift woven into the expansion of space-time itself. But galaxies, stars, and clusters might still carry the signature of that ancient spin. Another clue lies in dark energy, the enigmatic force causing the universe to accelerate. We do not know what dark energy is, but if our universe is the interior of a black hole, this acceleration may be a natural consequence of the black hole's growth. As more matter falls into the parent black hole, as its mass increases, the interior volume could expand more quickly. This expansion would feel, from the inside, like dark energy pushing galaxies apart. Then there is the mystery of information. Black holes store information on their horizons, not in their interiors. If our universe has a cosmic horizon that behaves the same way, we might detect hints of holographic structure, signs that space-time is shaped from its boundary inward. Some models of quantum gravity already point in this direction. We might also look for signs in the distribution of galaxies, the way matter flows along filaments, the curvature of space on the largest scales, and even the patterns of gravitational waves echoing across the cosmos. None of these signs are definitive. None confirm the idea. But each one whispers the same invitation. Look again. Look deeper. The universe might be more connected than it seems, and perhaps the most profound sign of all is simply this. The universe behaves like an interior, expanding rapidly at its birth, settling into smoothness, unfolding in a shape remarkably similar to the geometry expected inside a massive black hole. As you breathe gently, imagine the universe scattering clues like stardust, not to solve the mystery quickly, but to encourage a kind of cosmic contemplation, a way of seeing that blends knowledge with wonder. These signs may be faint, but they are there, waiting for patient eyes and a quiet mind. The universe, for all its complexity, seems to love symmetry. From the shapes of crystals to the structure of atoms, from the spirals of galaxies to the very laws that govern physics, patterns repeat, mirror, and balance themselves across scales. This deep sense of order, a quiet harmony beneath the chaos, may hold one of the most delicate clues about our cosmic origin. Symmetry is not accidental. It emerges when nature follows simple, elegant rules. Rules that do not change with time or place. Rules that mirror themselves as the cosmos unfolds. In particle physics, symmetries determine the fundamental forces. In cosmology, symmetries shape the large-scale structure of space-time. In black hole physics, symmetries define the geometry of horizons, the behavior of curvature, and the preservation of mass and spin. So what happens when we place these layers of symmetry side by side? A quiet picture begins to form, one in which our universe's symmetries may be hints of an inherited structure, passed down from the black hole that birthed it. 1. Symmetry and the laws of physics. The laws of nature appear the same everywhere in the universe. A star on the opposite side of the cosmos behaves like a star in our own sky. Particles follow identical rules, no matter where they're born. This universality looks very much like the interior of a system that inherited its rules from a singular uniform source, like the compressed interior of a collapsing star. 2. Symmetry in expansion. The universe expands in every direction at once, a perfect outward flow, as if the interior were inflating uniformly. This isotropy mirrors the geometric symmetry predicted inside certain black hole models, where expansion emerges evenly after collapse. 3. Symmetry in the cosmic microwave background. The oldest light in the universe is astonishingly uniform. Its temperature varies only in tiny ripples. This smoothness suggests a beginning from a perfectly balanced, highly compressed state, a hallmark of gravitational collapse. 4. Symmetry in the cosmic web. Large-scale structure forms an intricate pattern, yet even this complexity comes from simple initial conditions. Tiny fluctuations, symmetrical at the start, were stretched into the filaments we see today. Such patterned uniformity could be a reflection of the parent black hole's internal geometry. 5. Symmetry in black hole interiors. Inside a black hole, especially a rotating one, the geometry becomes highly structured, predictable in shape, consistent in curvature, deeply symmetrical. If our universe is such an interior, its large-scale symmetries would be fingerprints of that structure. 6. Symmetry as an inherited trait. If universes are born inside black holes, they inherit the mass and angular momentum of their parent. They might also inherit deeper symmetry properties, the ways in which the parent space-time curved, the balance of its gravitational field, the shape of its collapse. This would naturally explain why our universe feels so orderly, why it expands uniformly, why matter is distributed in predictable patterns, why the laws of physics appear unchanging across the cosmos. 7. Symmetry as a clue, not a conclusion. These patterns don't prove our universe came from a black hole, but they form a quiet harmony, a resonance between the structure of our world and the structure expected inside a rotating massive black hole. It's as if the universe carries the memory of its own formation in the elegant balance of its design. As you breathe gently, imagine that symmetry as a whisper, a soft clue pointing back toward an origin we can't see, a reminder that the universe may be shaped by a deeper order, a cosmic inheritance carried in every particle, every galaxy, every moment of space-time unfolding. Symmetry is not just beauty, it is information, and it may be telling us where we came from. When we look at the universe, we see a balance so delicate that it feels almost intentional, a cosmic middle path between chaos and stillness. The universe is not too smooth, yet not too clumpy. It has just enough structure for galaxies to form, but not so much that everything collapses. Stars ignite, planets stabilize, chemistry unfolds, and life has the space to emerge. Cosmologists call this delicate balance fine-tuning. But tonight, let's think of it more softly, as a sign that the universe carries the memory of the conditions that shaped it. If our universe formed inside a black hole, then its initial conditions were set by a collapsing star in a parent universe. And the collapse of a star naturally leads to the kind of just right structure we see today. Let's drift gently through why. 1. Collapse creates uniformity but not perfection. In a collapsing star, matter is compressed nearly evenly, but nearly is the key word. Tiny irregularities exist, microscale fluctuations in density, temperature, and pressure. Quantum tremors in the core, turbulent ripples in the falling plasma. When such a region opens into a new space-time, when a universe blooms inside, those tiny imperfections become the seeds of structure. Slightly denser regions become galaxies, slightly emptier regions become cosmic voids, slight temperature shifts become the map of the cosmic microwave background. A perfect collapse would create a perfectly smooth universe. But collapse is never perfect, and so our universe gains just enough asymmetry to grow stars and galaxies. 2. Expansion. Smooths but does not erase. Cosmic inflation stretches space, smoothing out differences, but it also preserves the tiniest fluctuations, amplifying them into the vast cosmic web. This balance between smoothing and preserving is exactly what you would expect from a universe emerging from extreme compression, then expanding explosively. 3. Gravity weaves structure. Without overwhelming it, gravity tries to pull everything together. Expansion tries to push everything apart. Their interplay is so perfectly balanced that galaxies form slowly, gracefully, without collapsing into chaos. This balance is puzzling if we assume the universe began from randomness, but it feels natural if its beginning was shaped by a gravitational system, a black hole interior, with precise inherited parameters, inherited mass energy, inherited spin, inherited curvature. 4. The universe is flat. But not too flat measurements show that the universe is almost exactly geometrically flat, but not perfectly. Just flat enough to expand forever, just curved enough to allow structure. A collapsing star naturally approaches this balance, becoming extremely dense and uniform, yet never perfectly so. 5. The cosmic web matches. Simulations of collapse. When scientists simulate universes formed from compressed initial states, the resulting large-scale structure looks strikingly like our universe today. Filaments, clusters, voids, all emerging from tiny inherited imperfections. 6. Just enough structure for life. This universe gives stars time to shine for billions of years, gives planets time to form and cool, gives chemistry time to evolve. This subtle stability may be another inherited trait. A universe born from collapse may naturally emerge with the gentle balance needed for complexity, for longevity, for life to wonder what life is. As you breathe softly, imagine the universe as a blossom that opened from the compressed interior of a collapsing star, shaped by forces that made it smooth enough to expand, but textured enough to give rise to stars, to planets, to consciousness. Our cosmos has just enough structure to hold everything we know, just enough harmony for light to gather into galaxies, just enough imperfection for creativity to exist. Not too much, not too little, just right. There is a boundary woven quietly into the fabric of our universe, a boundary not made of matter or energy, not a wall or a barrier, but a limit set by time itself. It is the cosmic horizon, the farthest distance from which light has had time to reach us since the moment our universe began. Beyond it, the universe continues, galaxies drift, stars shine. Perhaps other structures form, landscapes of matter and space-time we will never see, not because they are forbidden, but because the universe is not old enough for their light to have arrived. In this sense, the cosmos is like a vast sea whose distant shores remain hidden beneath the curve of the Earth, not unreachable, just unseen. But there is something deeper here. 1. The horizon is not fixed. Every moment, the horizon expands. New light arrives, carrying stories from farther and farther away. The universe reveals itself slowly, as though lifting a veil one photon at a time. Yet at the same time, space itself stretches faster than light can travel. distant galaxies are carried away more quickly than their light can approach us. They drift beyond the horizon, vanishing into cosmic silence. We see them now only because their ancient light is still catching up, whispers from a past moment that will never repeat. 2. A horizon that behaves like a black hole's. The cosmic horizon has no substance, but it behaves in ways reminiscent of a black hole's boundary. Information from beyond cannot reach us. Light cannot cross the expanding edge. Regions become permanently inaccessible. In a black hole, this boundary is an event horizon, where space-time curves inward. In our universe, this boundary is a limit set by expansion, space growing faster than light can traverse. And yet, the effect is strangely similar. Two horizons born from different mechanisms, but shaping reality in the same quiet way. 3. If we live inside a black hole, this makes sense. If our universe is the interior of a black hole, the cosmic horizon is its event horizon seen from the inside. From our perspective, we can never reach it. It is always the farthest point we can observe, a boundary that recedes as we approach, forever out of reach. From the outside, in the parent universe, that boundary would be the surface of the black hole, a shell of no return, holding within it the entire space-time we call home. We are sealed inside, but gently, not trapped, but enclosed, like a pearl inside a shell, spacious yet finite. 4. What lies beyond? This question is both simple and impossible. If our universe is the inside of a black hole, the outside is not another region of our universe but an entirely different cosmos, perhaps one with different physics, different structures, different stars and galaxies. A place where the black hole forming our universe sits at the core of a massive event, a collapsed star, a cosmic death that birthed our cosmic life. We will never see that place. Its light will never cross our horizon. Its story will always sit behind a boundary we cannot pass. And yet the idea offers comfort, for it means our universe has a parent, a lineage, a connection to something older, larger, deeper. 5. The horizon as a mirror. The cosmic horizon does not only hide, it reveals. Its uniform glow in the microwave background tells us what the early universe looked like. Its limits define where our information ends. Its expansion shapes the future. As you breathe gently, imagine that horizon not as a wall, but as a quiet mirror, reflecting what the universe once was, and reminding us that some mysteries are meant to hold their distance. What lies beyond our universe is one of the softest, most fragile questions we can ask. It feels almost like pressing your hand against a fogged window, trying to see through to a world that may not follow our rules, may not share our physics, may not even share our sense of space and time. If our universe is truly the interior of a black hole, then outside is not another region of our cosmos. It is something else entirely, a different realm, a different scale, a different story. Let's drift into that space gently. 1. The outside is not an extension of here. When we imagine the outside of the universe, we often picture a vast empty space, as though our cosmos were a bubble floating inside a larger room. But if our universe is a black hole interior, that image dissolves. Outside means the parent universe, the one in which the black hole formed, a universe with its own galaxies, its own stars, its own physics. We are not floating inside a larger chamber. We are inside the space-time formed by a collapse in another cosmos. 2. The parent universe might look nothing like ours. It could be older, younger, faster, slower, governed by laws that feel familiar or utterly alien. Its matter might behave differently. Its forces might be stronger or weaker. Its dimensions might be more numerous or fewer. In some models, the parent universe is similar to ours, a place where stars live long lives, where gravity shapes galaxies and black holes form as natural endpoints. In other models, The parent universe is almost unrecognizable, a chaotic realm where physics unfolds differently, or a higher dimensional space where black holes appear as projections or shadows. 3. The black hole, that birthed us as a star, but bigger. In the parent universe, our entire cosmos would be contained within a black hole formed from the collapse of a massive star, perhaps millions of times more massive than our Sun. To an observer in that universe, our entire universe would look like a dark sphere, floating silently in the fabric of their own space-time. They would never know that inside that darkness lies a vast and expanding cosmos, with galaxies, life, consciousness, and beings like you wondering where everything began. 4. We cannot communicate with the outside. The event horizon of a black hole is absolute. Information cannot travel outward. Light cannot escape. Space and time inside flow differently than those outside. This is why the outside remains forever veiled, not hidden maliciously, but hidden by the very structure of space-time. If we are inside a black hole, then our cosmic horizon is that event horizon, and no message we send, no photon, no signal, no atom, can ever cross it. We are sealed, but in a gentle way, like a universe cradled inside a cosmic womb. 5. A universe. Within a universe, within a universe. If black holes create new universes, then our parent universe may itself be inside a black hole of an even older universe, and that universe may be inside another, and so on, endlessly. A cosmic nesting doll of realities, each contained inside the collapsed core of the one before it. This view evokes a sense of quiet infinity, not infinite space, but infinite generation. 6. And what of us? What does it mean to exist inside a structure that sits inside another that sits inside another? It means we are part of a lineage, not isolated, not alone, but connected through the quiet geometry of collapse and creation. It means our universe has ancestors, and perhaps descendants yet to be born. As you breathe gently, imagine the outside not as emptiness, but as ancestry, a wider cosmos whose collapse gave birth to ours, a place we will never see but from which every atom in your body quietly descends. In the calm hours of the night, when the universe feels both infinite and intimate, a gentle idea begins to form, one that stretches across realities like branches of a cosmic tree. It suggests that the multiverse, if it exists, may not be a chaotic sprawl of random worlds, but a quiet lineage, a family grown through the simplest and most natural process in the cosmos, the collapse of stars. Imagine a universe much like ours. Galaxies shimmer, stars burn for millions or billions of years. Then, one day, a massive star exhausts its fuel. Gravity begins its slow reclaiming. The star collapses, curves inward, and a black hole forms, a region that from the outside looks like an ending, but inside something extraordinary might occur. 1. Black holes as seeds. In many theories, the interior of a black hole may not be a singular point at all, but a space-time seed, a kernel of geometry ready to blossom into its own expanding universe, a place where the inward fall becomes outward growth, a place where time begins again. If this is true, then every black hole that forms becomes a seed of a new universe, each one unfolding on its own timeline, forever sealed behind an event horizon. 2. A tree of universes born from collapse. Now imagine the sheer number of stars in our universe, billions of galaxies, trillions of stars, and within them, countless black holes forming over cosmic history. If every black hole births a universe, then the multiverse grows like a tree, branching through time, each branch a universe, each universe filled with stars that create branches of their own. Our universe would be one leaf on this unimaginable tree, born from the collapse of a star in a parent universe, fated to create universes of its own. 3. Cosmic natural selection. Some thinkers imagine an even deeper process. Universes that produce many black holes would have many descendants. Universes that produce few would have fewer. Over cosmic generations, universes with physical laws that favour star formation, and therefore black hole creation, would become more common. It is a kind of natural selection on a cosmic scale. Not biological evolution, but evolutionary physics. In this picture, our universe may exist because it is good at making stars, because it is particularly fertile in producing the black holes that allow universes to reproduce. 4. A multiverse without chaos. This view brings order to the multiverse. Instead of random worlds with wildly different laws, we get families of universes connected by inheritance. Each generation inherits the mass structure of its parent star, the angular momentum of its collapse, the initial density conditions created by gravitational compression, and perhaps even the physical constants that determine how matter behaves. This inheritance offers a soft explanation for why our universe feels finely balanced, why gravity is just weak enough, why forces align so precisely, why matter organizes itself into galaxies, why stars burn steadily for billions of years. Our universe may simply be the descendant of a long line of stable, fertile universes, members of a family tree shaped by black hole creation. 5. The quiet beauty of this idea, what makes this picture so serene, is that it does not require exotic particles or strange new physics. It flows naturally from what we already know. Stars collapse, black holes form, black holes hold mass and spin, and space-time near them behaves in predictable patterns. From these simple ingredients, a multiverse of inheritance unfolds, a fractal tapestry of universes within universes. 6. And us within it all. If this is the structure of existence, then you, right now, are part of a lineage that stretches across unimaginable scales. Your atoms were forged in stars. Your universe was forged in a star beyond stars. And the black holes in our own sky may, even now, be creating realities where new forms of existence drift through new horizons. As you breathe softly, imagine the multiverse not as chaos, but as a quiet, branching family. Each universe a child of collapse, each collapse a doorway into creation. When we ask whether we are inside a black hole, the question touches something deeper than physics. It brushes against the very way we experience reality, the sense of being here in a body, in a mind, moving through a world filled with shape and meaning. But what does inside truly mean? For consciousness, the boundary between inside and outside is softer than we think. When you close your eyes, your awareness turns inward, yet the world outside still exists. When you breathe, air flows from outside to inside, becoming part of you for a moment before returning to the world. We are not sealed containers, we are exchanges, flows of energy, breath, sensation, and the universe itself may be the same way. 1. Inside and outside are relational ideas. In everyday life, inside means surrounded by walls, held within a boundary, a room, a shell, a sphere. But in space-time, boundaries are not physical objects. They are conditions, curvatures, relationships between observers. A cosmic horizon doesn't enclose us like a box. It defines the limit of what we can see, not the limit of what exists. So even if we are inside a larger space-time, inside a black hole of a parent universe, we don't feel enclosed, we feel infinite. 2. Consciousness lives within horizons of its own. Your mind also has horizons, limits beyond which you cannot see. There are memories beyond recall, worlds beyond experience, future moments beyond understanding. Yet you live comfortably inside these horizons. You do not feel small because you cannot access everything at once. In this way, consciousness and the cosmos mirror each other. Both have boundaries, both exist within limits, and neither requires access to the outside to feel whole. 3. Inside a black hole. Reality is still complete. If our universe is an interior space-time, then everything we will ever know, every star, every galaxy, every moment, every thought, arises from within this interior, and that is enough. From the inside, a black hole universe feels open, vast, expanding, full of structure and possibility. We never see the boundary. We never feel confined. We never sense the parent universe beyond. Just as a child in a womb experiences a complete world, our universe feels full because we are born into it. 4. Consciousness is always inside something. Inside a body, inside a mind, inside a culture, inside a planet, inside a solar system, inside a galaxy, inside a cosmos. Each boundary shapes us, yet none of them diminish us. In fact, boundaries are what allow experience to exist at all. Without the interior of a mind, there would be no sense of self. Without the interior of a universe, there would be no place for galaxies, no physics, no time. Being inside is not confinement. It is the condition that allows structure to form. 5. The universe as a container for awareness. If our universe is inside a black hole, then this cosmic interior is our cradle, the environment that gives rise to consciousness itself. The atoms in your brain were forged in stars. The elements that build your body were shaped by expansion and cooling. Your thoughts drift through pathways illuminated by ancient nuclear furnaces. You're not separate from the universe. You're a continuation of it, a flowering of matter into awareness. 6. Inside becomes meaning. Perhaps the question is not, are we inside a black hole? But rather, what does it mean to exist inside anything at all? To be inside is to belong, to be held, to be part of a structure larger than yourself, to be woven into a physical story that stretches from collapse to expansion to consciousness. As you breathe gently, imagine that your awareness is a ripple in a vast interior space-time, a universe that may itself be a ripple in an even larger reality. Inside, outside. The distinction softens, and what remains is connection. Time is the quiet current that carries everything forward. It is the unseen river that shapes our days, guides our memories, and whispers the rhythm of our existence. We do not see time, we feel it. In every inhale, in every thought, in every sunrise that returns with gentle predictability. Yet, in the deepest layers of physics, time is not uniform. It is not absolute. It is not even guaranteed to flow the same way everywhere. Time stretches, bends, slows, and accelerates depending on gravity, motion, and the geometry of the cosmos. And if our universe was born inside a black hole, then the flow of time we experience today may be part of a larger cosmic pattern, a breath drawn across realities. 1. Time near a black hole slows. In strong gravitational fields, time behaves differently. A clock near a black hole ticks more slowly than a clock far away. Seconds stretch, moments linger. The deeper the gravity, the gentler the passage of time. This slowing is not illusion. It is written into the geometry of space-time itself. Now imagine the moment a black hole forms, a star collapsing, gravity intensifying, time stretching outward near the horizon and inward near the core. At the threshold of collapse, time bends almost to stillness, and then something remarkable may happen. 2. Inside, time turns and becomes new. In some solutions of general relativity, once matter passes the horizon, the direction of time changes meaning. The inward plunge, the fall toward the singularity, becomes the natural direction of time. Falling inward is not a choice, it is the future. But if the singularity becomes a bounce or a new region of space-time, or the spark of a fresh universe, then time itself is reborn. From the perspective of the new universe, the Big Bang is the first moment of time, a beginning that feels absolute, but may simply be the continuation of a cosmic flow. 3. The universe expands like an exhale. After the Big Bang, space begins to expand, rapidly at first, a burst of inflation, a sudden stretching that smooths everything out. Then more gently, the expansion slows. Later still, it accelerates again. This alternating rhythm, fast expansion, slow cooling, renewed acceleration, resembles the long tides of a breath. Inhale, exhale, pause, flow again. Perhaps our universe is breathing along the curvature of a black hole interior, its expansion guided by the geometry it inherited. 4. Time as something the universe creates. If our universe is the inside of a black hole, then time is not an external dimension we move through. It is something generated by the unfolding of space-time itself. Time emerges when collapse becomes expansion. It stretches with space. It is shaped by horizons. It is influenced by mass, motion, and rotation. In this view, time is like a cosmic breeze, born from geometry, carrying us forward, filling the universe with direction. 5. And consciousness rides, this breath. Your thoughts flow along this cosmic timeline. Your heartbeat syncs with it. Your memories gather behind you. Your hopes drift ahead, all carried gently by the river of time. You are not separate from the universe's breath. You are part of it. A moment of awareness rising in the middle of a cosmic inhale. 6. The breath never ends, it transforms. If universes are born inside black holes, then each universe begins with a sharp inhale, a rush of expansion, a bloom of space-time. And when stars collapse in that universe, they create new interiors, new breaths, new timelines, new cosmic currents. Time flows, turns, and begins again in cycle after cycle, unseen but uninterrupted. As you breathe softly now, imagine your breath as one small echo of the universe's own expanding interior, a reminder that time, like breath, is both a motion and a mystery, carrying you gently forward through the vastness of creation. Light is the great traveller of the cosmos. It moves through space with unwavering devotion, carrying messages from distant stars, memories from ancient galaxies, and whispers from the first moments of time. Even when matter falls, even when stars die, even when universes rise and collapse, light continues its journey. It never stops trying to escape, to reveal, to illuminate. When we imagine our universe as the interior of a black hole, a new and poetic idea forms. Light may travel across universes, not as a beam moving from one cosmos to another, but as an influence, a memory, a pattern encoded in the very curvature that shapes each new space-time. Every time a universe is born from collapse, the geometry of that collapse carries subtle imprints of the light and matter that fell inward. These imprints are not photons in the usual sense, but the information carried by them, energy, momentum, spin, folded into the space-time that blossoms inside. In this sense, light's journey does not end at an event horizon. It transforms. Think of light streaming through the parent universe. Some of it falls into the dying star that will eventually form the black hole. As it spirals inward, it stretches, reddens, and slows. At the horizon, it becomes part of the black hole's quantum state, its information preserved on the surface. And when the interior opens into a new universe, the patterns of that preserved information may seed the fluctuations that become galaxies, stars, and planetary systems. The faint ripples in the cosmic microwave background, those delicate variations that shaped everything we know, could be echoes of this inherited information, the final whispers of light that existed before our universe began. Even within our universe, light continues this endless migration. Photons from the Big Bang travel through space, cooling and stretching into microwaves as the universe expands. They pass by galaxies, flow through clusters, bend around massive objects, and carry the curvature of space-time imprinted onto themselves. Light doesn't merely move through the universe, it maps the universe. Each photon's path is shaped by gravity, expansion, and time. When we observe that light billions of years later, we read those shapes back, reconstructing cosmic history from every shift in wavelength and direction. If universes emerge from black holes, then this cycle never ends. Light in the parent universe influences the collapse of stars. That collapse creates a new space-time. The new space-time inherits the curvature shaped by that light's momentum. The new universe forms stars that shine again. Their light travels, carries information, shapes gravity, and eventually some of those stars collapse into black holes that birth new universes. The journey of light becomes generational, not a path from point A to point B, but a flow through cosmic ancestry. And there is something beautifully human in this idea. Just as your thoughts carry the influence of memories, and your life carries the influence of lives before you, each universe carries the influence of the light that shaped its birth. Light is not merely illumination, it is inheritance, it is continuity, it is memory woven into geometry. As you breathe gently, imagine every photon as a thread in a tapestry that stretches across realities, a quiet messenger whose journey never truly ends, only transforms, through collapse, through expansion, through the birth of new universes. Light continues its endless pilgrimage, carrying stories written in curvature, energy, and time. Even now, the light that reaches your eyes has travelled across incredible distances, surviving the pull of gravity, the stretch of expansion, and the silence of cosmic epochs. You're witnessing part of that infinite journey, the shimmering echo of creation flowing softly through the dark. If our universe was born inside a black hole, then everything we see, every galaxy, every star, every atom, may carry a subtle memory of the universe that came before. Not a conscious memory, not something written in words or symbols, but a deeper kind of remembrance, encoded in the geometry of space-time and the behaviour of matter. Just as a child inherits traits from a parent, a universe may inherit traits from the collapsing star that birthed it. Imagine the final moments of that star in the parent universe. It swelled, burned, collapsed. Its layers folded inward, forming currents of rotation, streams of turbulence, swirls of magnetic fields. As the collapse intensified and a black hole formed, the star's mass, spin, and pressure became imprinted into the newborn horizon. These properties would not disappear, they would be preserved. Mass becomes gravitational potential, spin becomes angular momentum, turbulence becomes subtler symmetry. And when the interior opens into a new expanding space-time, those imprints shape the early conditions of the universe inside. Our early universe, then, is not random, it is patterned. It remembers the collapse that birthed it. Perhaps the uniformity of the cosmic microwave background, the slight variations that seeded galaxies, and the faint hints of cosmic rotation are all echoes of the parent star's final moments. The incredibly smooth temperature of the early universe may reflect the near-uniform density of a collapsing stellar interior. The tiny fluctuations in that glow, the ones responsible for forming every galaxy, could be the fingerprints of quantum noise and turbulence inside the parent star's collapsing core. Even the possible rotation of our universe, hinted at by the unusual spin distribution of certain galaxies, may be an inherited twist, a gentle memory of the angular momentum of the star that died before we were born. This idea is not fantasy. It is grounded in the mathematics of general relativity. A black hole preserves only two major features of everything that falls in: mass and angular momentum. Those features define the geometry inside. If the newborn universe inherits that geometry, then the shape of its expansion, the distribution of matter, and even the constants that govern its physics may carry clues about its parent universe's collapse. Our cosmos might not just remember that it came from somewhere, it might remember how. In this sense, the Big Bang is not the beginning of everything, but the beginning of our branch of the cosmic family tree. The initial conditions of our universe, the density, the curvature, the smoothness, the slight imperfections, are like the inherited traits of a newborn. They reflect what came before, even though we cannot see beyond our horizon. We cannot observe the parent universe directly, just as we cannot observe our own infancy, but its influence is present in every structure we see. There is a quiet comfort in this view. It means the universe is not isolated, not lonely, not without origin. It means we are part of a lineage, a cosmic ancestry stretching through generations of stars and universes. Even the atoms in your body are part of this memory. The carbon in your cells, the iron in your blood, the calcium in your bones, all forged in stars of earlier epochs, are now drifting through a universe that itself was forged in a star before stars existed. As you breathe gently, imagine the universe as a child remembering its parent not through stories, but through structure, through the way it expands, rotates, and glows. A quiet cosmic inheritance, carried forward through collapse and creation, shaping everything from the largest galaxy cluster to the smallest spark of consciousness within you. When we imagine existence, we often picture it as a single continuous expanse. One universe, one reality, one vast space stretching outward without end. But if every black hole gives rise to a new universe, and if universes can exist inside the horizons of others, then existence may be something far more intricate, layered, and interconnected. Rather than a single infinite plane, reality might be a set of nested interiors, worlds within worlds, each contained inside the gravitational heart of another. Think of Russian nesting dolls, each resting within a larger one. Now expand this concept beyond simple shape. Imagine each doll not as a physical container, but as an entire space-time, complete with its own laws, its own timelines, its own galaxies. Inside each universe, stars collapse into black holes. Inside each black hole, a new universe blooms. Every layer unfolds into another, not stacked mechanically, but blossoming organically. Like petals forming within petals, each carrying the memory of the one before it. If this is true, then our universe is both a whole and a part. It contains everything we know, yet it may itself be contained. It holds galaxies, yet it may sit quietly inside the core of a collapsed star from a parent universe, and the black holes within our own cosmos may house their own interiors. Entire universes unknowable to us, each with their own horizons, their own expansion, their own cosmic webs of matter and light. This nested structure reframes how we think about size. The universe feels immeasurable to us because we live inside it, embedded in its expansion. But in a parent universe, the black hole that contains us might be just one object among countless others, just as our black holes appear as points of darkness in our sky. Scale becomes relative. What seems infinite from within may be finite from beyond. What seems vast may be tiny when viewed from another level of the nested whole. It also reframes how we think about beginning and end. In a nested cosmos, beginnings are transitions and endings are transformations. A star's death becomes the seed of a universe. A singularity becomes a doorway. A black hole becomes a womb for a new space-time. Nothing ends. It flows from one form into another, like water moving through different vessels, always finding a new way to exist. Most profoundly, this nested wholeness deepens the sense of connection. You're not just part of a galaxy or a universe, you're part of a larger tapestry of interconnected realities. The atoms in your body come from stars in this universe, but the laws that shape your body, the constants of physics that define matter, energy, and time, may come from the collapse of a star in an entirely different universe. And the black holes in our universe may one day generate new universes shaped partly by the physics of our own. Existence, then, is not a line but a spiral, a recursive pattern where structure emerges within structure, where universes give rise to universes, where every interior holds the potential for another horizon. And just as each cell in your body holds the entire genetic code of your being, each universe may hold within its structure the encoded memory of everything that preceded it. As you breathe gently, imagine existence not as a single cosmic stage, but as a nested cathedral of realities, each layer holding, shaping, and giving birth to the next. You are part of this whole, a moment of awareness inside a universe that may itself rest inside another, all of it flowing with quiet continuity, all of it connected through the symmetry of collapse and creation. When we drift through ideas as vast as universes inside black holes, horizons beyond reach, and cosmic ancestry stretching through countless generations, it's easy to feel small, like a single grain of dust floating inside an endless cathedral of stars. But the truth is softer, deeper, and far more intimate. You're not outside this story. You're not an observer standing apart from the cosmos. You're woven into it. Every part of your being is connected to this cosmic lineage. Begin with your atoms, the carbon in your cells, the oxygen you breathe, the iron flowing quietly in your blood. All of it was forged in the hearts of ancient stars. Those stars lived, burned, and collapsed long before Earth existed. Their ashes became the material for new systems, new worlds, new life. You are, in the most literal sense, made of star remnants, a living continuation of cosmic chemistry that stretches back billions of years. But if our universe itself was born inside a black hole, then your story extends even further. The laws that govern your atoms, the strength of forces, the masses of particles, the geometry of space-time, may reflect the collapse of a star in another universe. Your existence carries the imprint of a cosmic ancestor you will never see. You're built from the memories of a universe that collapsed, bloomed, and gave rise to the space-time you now inhabit. And then there is your consciousness, the quiet field of perception through which you experience everything. Neuroscience tells us the brain is a network of cells, signals, and chemistry. Physics tells us those cells obey the laws of the universe. But awareness itself, the simple act of experiencing a moment, is something deeper. It is the cosmos becoming aware of its own structure. You're not separate from the universe exploring its own origins. You are the instrument through which it does so. When you gaze at the night sky, your mind is interpreting light that has been travelling for billions of years. Some of those photons began their journey when the universe was young, cooling from its initial expansion. When you ponder where the universe came from, you are participating in the very process that shaped it. Curiosity arising from complexity, complexity arising from matter, matter arising from a cosmic beginning that may itself have been the interior of a collapsed star. You're not small in this story. You're central to it, not because the universe was made for you, but because you are one of the ways the universe becomes capable of reflection. Without consciousness, the cosmos would be silent about its own origins. Through you it wonders, through you it questions, through you it becomes aware that it may have parents and descendants, horizons and interiors, beginnings and transformations. And consider this: if every black hole might create a universe, and if universes give rise to stars, and stars give rise to life, then consciousness may be one of the rare gifts that emerges naturally from this nested structure. You are the flowering of billions of years of cosmic evolution, not random, but the result of structure, stability, and time. As you breathe gently, imagine yourself not as a separate being inside the universe, but as a unique way the universe looks back at itself. You are part of this cosmic lineage, made of starlight, shaped by collapse, carried by expansion, and capable of understanding the story written in the geometry of space-time. You are the universe reflecting on its own existence, a quiet miracle drifting beneath a sky full of ancient light. There is a gentle freedom in admitting that we do not know everything. In a universe as vast and layered as ours, perhaps nested within other universes, perhaps birthing universes of its own, certainty becomes a small island floating in a sea of possibility. And yet not knowing does not diminish us. It softens us. It opens us. It gives us room to breathe. Science thrives on questions. Curiosity is the engine that moves our understanding forward. But curiosity does not need to be driven by urgency or fear. It can drift, like starlight across a quiet horizon, motivated not by the demand for answers, but by the simple wonder of existence itself. When we explore ideas like, are we living inside a black hole? We are not grasping at final truths. We are engaging in a conversation with the universe, listening for echoes, patterns, clues, and gentle hints. The truth is, there are limits to what we can know. Our cosmic horizon draws a boundary around what information can reach us. Light from beyond cannot arrive. Space expands too quickly. Time flows in only one direction. The universe reveals its story slowly, only as far as light and physics allow. And perhaps this limitation is not a flaw, but a feature. Without it, there would be no mystery, no imagination, no room for wonder. Without boundaries, existence would be flat and complete, with nothing left to explore. Even within ourselves, knowledge has horizons. There are memories we cannot access, futures we cannot foresee, thoughts that arise without warning. The mind is shaped by limitations as much as by capacity. We do not know every reason behind our emotions, every pattern behind our choices, every quiet shift in our inner worlds. But we live fully even without perfect understanding. We grow, we reflect, we breathe. The universe, in this sense, mirrors us. Its unknowns are not obstacles but invitations. The fact that we cannot see beyond the cosmic horizon invites us to imagine what might lie outside. The fact that we do not understand dark energy invites us to wonder whether it is a horizon effect. The fact that we cannot observe the interior of black holes invites us to consider that they might be birthplaces of new universes. Our lack of certainty becomes fertile ground for insight and creativity. There is peace in this, a sense that we do not need to solve everything to feel connected or safe. The cosmos does not ask us to understand every detail. It only asks us to observe, to listen, to sense the flow of existence and allow ourselves to be part of it. Knowledge and mystery are not opposites. They are partners in a cosmic dance. Where one leads, the other follows. Even the greatest scientists, Einstein, Hawking, Penrose, lived with enormous unknowns. What they understood deeply was that the unknown is not darkness. It is possibility. It is potential. It is the blank canvas upon which new ideas gently take shape. So as we reflect on the possibility that our universe may sit inside a black hole, remember that we are not required to know. We are only invited to wonder. The beauty of the night sky is not diminished by our inability to name every star. The beauty of existence is not diminished by what lies beyond our reach. Let the vastness soften you. Let the mystery calm you. Let the not knowing be a space where your thoughts can drift freely, like luminous dust moving through starlight. There is peace in this openness. A peace that comes from accepting that the universe is larger than certainty, and that you are allowed to rest gently within its mystery. As our journey gently circles toward its close, we return to the question that opened this quiet exploration. Are we living inside a black hole? When you first heard it, it may have sounded like a strange thought experiment, something distant, speculative, almost fantastical. But now, after drifting through horizons and collapse, through quantum foam and cosmic ancestry, the question feels softer. Not a riddle to solve, but an invitation to wonder. What have we discovered along the way? That black holes are not simply cosmic abysses. They are regions where space-time curves into new shapes. That inside their horizons, time flows differently, geometry shifts direction, and new regions of space-time may unfold. We learned that the size of our observable universe matches the size a black hole of our mass would have. That the smoothness of the cosmic microwave background resembles the interior of extreme gravitational compression. That the accelerating expansion of the universe may be a natural continuation of a black hole, interior, growing as its parent black hole gains mass. We saw hints, faint but intriguing, that our universe may carry a slight rotation, possibly inherited from the collapse of a star in a parent cosmos. Piece by piece, the story became more coherent. Not confirmed, not proven, but meaningful in its harmony. The universe behaves in ways a black hole interior is predicted to behave. The cosmological horizon mirrors the event horizon of a black hole. The flow of time aligns with what happens when collapse transforms into expansion. The structure of galaxies follows the type of geometry a rotating black hole interior would produce. And the quiet, delicate balance of physical laws feels less like randomness and more like inheritance. So are we inside a black hole? Perhaps the more refined question is not whether this is true or false, but what it means if the universe behaves like one. If our universe has horizons that act like event horizons, if its expansion mirrors interior volume growth, if its initial conditions resemble a collapsing star's interior, if its global properties match those preserved by black holes, then maybe the label matters less than the structure. Maybe the truth lies in understanding how deeply connected collapse and creation can be. If this idea is true, then our universe is part of a lineage, a cosmic genealogy stretching back through realities we will never see. Our cosmos may be one branch of a multiverse grown through the quiet process of stellar collapse, and the black holes we observe in our own night sky may be pregnant with universes yet unborn, each carrying the physical patterns of this one. If the idea is not true, it still gives us something precious: perspective. It reminds us that the universe is layered with mysteries deeper than our senses can grasp. It shows us that our cosmic horizon is not a limit to imagination. It teaches us that the world may be richer, stranger, and more interconnected than we once thought. Most importantly, this question brings us back to ourselves, to the breath moving through you, to the awareness listening now, to the simple, undeniable fact that you exist inside a universe expanding gently around you, whether it is inside a black hole or not. And that universe gives you a place to rest, to wonder, to become conscious of your place within something immeasurably vast. As we return to the first question, the answer becomes less important than the feeling it evokes. Curiosity softened by calm, wonder held within stillness, a sense that the universe, whatever its origin, is a place that allows you to drift through existence with a quiet heart. Across all the vastness we've explored, black holes, horizons, quantum foam, cosmic ancestry, one feeling keeps rising gently to the surface. The universe is a quiet home. Not a random expanse of emptiness, not a cold machine, not an indifferent void, but a spacious, unfolding interior where every particle, every star, every breath finds its place. If our universe is inside a black hole, then this home is even more intimate. It means we live inside a cosmic sanctuary, a region shielded from the parent universe outside, a place where space-time has opened into a safe and expanding interior. This interior is not harsh or violent. It is gentle enough to form galaxies, stable enough to nurture stars, balanced enough to allow planets to cool, oceans to gather, and life to emerge. The universe doesn't feel like a prison, it feels like a cradle. Everywhere you look, the cosmos offers signs of its quiet hospitality. Stars burn with long, steady light, giving warmth and energy to worlds that orbit them. Galaxies arrange themselves into vast spirals and graceful clusters, like luminous neighborhoods in an endless night. Even empty space is not hostile. It holds everything together with soft pressures and gentle flows. Expansion doesn't rip the world apart. It creates room for new structure to form. This sense of gentleness is not sentimental. It is physical. The gravitational field in our universe is incredibly weak compared to the strength of other forces. The balance between expansion and gravity is delicate, allowing just the right amount of structure. The laws of physics appear fine-tuned for stability, supporting complex chemistry and the long, slow evolution of life. These conditions feel almost like the soft interior of something larger, as if our universe is protected by its own horizon, insulated from extremes. If this is indeed a black hole universe, then the event horizon surrounding us is not a barrier meant to confine. It is a boundary that keeps the interior calm. It filters the chaos of the parent universe. It seals us in a region where space-time can stretch into harmony. Inside that boundary, we have room to grow. Galaxies, stars, life, and consciousness, all unfolding on their own schedules. And even if this idea is not literally true, the metaphor carries a truth of its own. The universe feels like a place designed for emergence. It has the quiet patience required for atoms to form, for stars to ignite, for planets to cool, for life to learn, for awareness to rise. It is a home not in the sense of a structure built for us, but in the deeper sense of being a place where existence can take root. When you step outside at night and look up, you are gazing into this vast interior. Every point of light is part of the same unfolding structure that cradles your life. The space between stars is not empty in a lonely way. It is empty in a generous way, offering room for galaxies to drift and evolve over billions of years. You're surrounded by this quiet home everywhere you go, in the atoms of your body, in the breath moving through you, in the space around your hands, in the starlight that reaches your eyes. Whether we are living inside a black hole or simply inside a universe with its own gentle architecture, the feeling is the same. You are held. You belong here. You are part of this unfolding interior. As we drift toward the final chapter of this journey, let that feeling stay with you. The universe is not something you stand apart from. It is the quiet space that holds you, shapes you, and invites you to rest within its deep and patient silence. As our journey drifts toward its final moments, imagine the universe around you softening into a single breath. The galaxies we explored become distant lanterns. The black holes become quiet gateways. The cosmic horizons blur into a gentle twilight, and you, floating here, listening, breathing, become part of the same stillness that holds everything together. We began tonight by wondering whether our universe might live inside a black hole. Along the way, we wandered through the curved geometry of space-time, the bloom of new universes from old stars, the whisper of quantum foam at the boundaries, the inherited memories written into cosmic structure, and the subtle rotation that might echo across billions of light years. Each idea led to the next like stepping stones across a calm river, guiding us deeper into a world where collapse becomes creation, where horizons become transitions, and where every beginning is the quiet continuation of something older. But now, as the night settles around you, the answers matter less than the feeling they leave behind. The universe may be a black hole interior, or it may be something even more mysterious. The details may shift as science progresses, as theories evolve, as new clues come to light. But the essence remains constant, The cosmos is vast, gentle, and deeply interconnected. It is a place where beautiful structures emerge from ancient forces, where stars are born from clouds that collapse, and where life, your life, rises from atoms forged in long-forgotten suns. In this quiet moment, let the magnitude of that truth soften your thoughts. You are part of a cosmic lineage stretching across unimaginable distances and timescales. You're shaped by processes older than galaxies. You're held within a universe that expands with patient grace. And whether this universe sits inside a black hole or rests on its own, it offers you space to breathe, to wonder, to dream. Let your breath slow. Let your shoulders release. Let the edges of your awareness settle like dust drifting to the floor of a silent chamber. Feel the weight of your body supported by whatever you lie upon. Feel the steady rhythm of your heartbeat, a small but undeniable proof that you are alive inside this immense interior. The same laws that shaped galaxies also shape that beat. The same gravity that guides stars also guides the breath moving through you. You are not separate from the universe. You never were. You're a quiet expression of it, a moment of awareness inside a cosmic story still unfolding. The night sky above you is not distant. It is part of the same fabric you are woven from, and whether you are awake or drifting into sleep, you are carried by the same currents of space-time that cradle galaxies and carry starlight across eternity. So let go now. Let the universe hold you in its gentle expansion. Let your thoughts drift like soft dust across a sunbeam. Let the mystery of existence become a blanket around your mind, warm, calm, weightless. There is nothing you need to solve, nothing you need to understand. Only the quiet rhythm of being here, alive, conscious, floating in the cradle of a universe that may itself be floating inside something far beyond imagination. Everything flows. Sleep in that motion.